Dear friends and the student community of ESE, all the students who wrote today, I hope you wrote the paper very well and you are eager to argue with us the solutions and analysis of ESE 2022 Department of Electrical Sciences. Myself, B.S. Krishnavarma, Faculty of ACE Engineering Academy since 2009. Today I would like to analyze the entire question paper with my great team with so much of experience and qualification. As you know, yes, we got the paper at evening 5, and after rigorous analysis and a lot of discussion with our team, we came to a great conclusion and very accurate analysis. The term I use is from ACE Academy, we can challenge and guarantee you very accurate analysis to this question paper. We got set D. From that set D, we did analysis. Of course, the sequence of questions may vary in different sets, but the marks division. Now, before we go to introduction of our team, I try to give the marks division here. Now, yes, this is ESE 2022 Prelims, and you know there is no calculator here. Yes, the subject right, electrical, in that maths, engineering mathematics, yes, in 2022, 12. You see the average here, generally it is 12 to 15, only in 2021 it is 15, but it is 12 now, which is very accurate. Electrical materials, yes, 14. Electric circuits and fields, 8 plus 3. So circuits came 8 questions and fields 3. Electrical and electronic measurements, 12. Computer fundamentals, 12. Basic electronic engineering, 15. Communication and microprocessor, 10 plus 1. So microprocessor 1 bit. And signals, systems and signal processing, 14. Control systems, 12. Electrical machines, of course, the most core important subject, 13. Then power system, 12. Power electronics and drive, 12. So this time, yes, you can find a very even distribution of marks. One good thing, this after the change in syllabus in ESE since 2016, one good thing we identify is there is a beautiful even distribution of marks. That is really fantastic, and the standard of ESE has increased a lot. So yes, to get first rank, you know that it is not possible to attempt every question, but whatever best you can do in the minimum available time with common sense, you will be the winner. Now I would like to introduce our great team of electrical department of ACE Engineering Academy.
Hello, good evening students. Myself Khadar Basha. I am taking electrical machines in ESE Engineering Academy. Now let's see here. So first of all, if you talk about the weightage, so almost same like previous years we got this year also. But I am little disappointed that there are no questions from transformers first. Not only in ESE this year, but also in the gate examination of the 2022, we don't have any question from transformers. Okay, so it will happen sometimes based on the whoever will give the paper for gate or ESE. Now let's see some questions from electrical machines. Around 13 questions we got from electrical machines this year. So almost all questions are just very easy questions. Okay, so let's see the first question. In a lap winding, there are always as many paths in parallel through the armature winding as there are number of poles. In such a lap winding, the current in each armature coil. See, what is the answer? Yes, very simple. So, if the winding is lap connected, how many parallel paths will be there first? Equal to number of poles. Okay, then what is the current? If you take the total armature current outside is IA, then that current will divide into number of parallel paths. That is IA by capital A. But what is the parallel paths in case of lap connection? Equal to poles. Now, if you see from this, observe here. So we have equal to armature terminal current, that is output current of armature only, divided by the number of poles. Okay, so option C is correct. So number of parallel paths is A, that is equal to poles. That's why the current in each parallel path is IA by P, number of poles. Clear? Next question. A 4-pole DC machine has 54 slots in armature. It is lap wound with single turn coils. Okay, here it is single turn coils. So number of coils is equal to directly number of turns. How many armature coils are required? So very simple one. How many armature coils required? So number of armature coils is equal to half of the slots. How many slots are given in this? We have 54 slots. So 54 by 2, nothing but 27. Okay. 27 coils required, which are single turn coils. Okay, so generally in single turn coils, it is only possible of single layer winding, but not double layer winding. So we know in single layer winding, always number of coils equal to half of the slots. That's why it is 27 here. Okay, next question. See here. So in this question, the question may be the magnitude having more lengthy one, but in this we required very less data. Okay, just read the complete question once. A DC shunt motor is rated for 230 volts, 1350 RPM, 10 HP. So these are all rated values. The line current is 37.5 ampere and the field current is 0.75 amperes. Okay, it is known that the armature resistance is 0.35 and given field loss is 519 watts at rated speed. The shunt DC motor is to be equipped with a manually operated variable resistor starter. So we are using one starter to limit the armature current. So straightforward the question in this, what is the maximum allowable armature current in starting resistor to assure that initial armature current does not exceeds 150% of the rated value. So first you need to find in this what is the rated armature current. Calculate from the given data. IA equals to, so we have the line current and also field current, IL minus ISH. What is the value of IL is 37.5 minus 0.75. So we get it is 36.75 amperes. Okay, this is the rated armature current. But up to what we have to limit maximum value using starter? 150%. So calculate the maximum allowable current is 1.5 times of this 36.75. So calculate if you observe. So here by observing options also you can tell directly the answer. Okay. So these are all less than 36.75. That's why it is not the correct. The correct one is directly here you can say option D. Okay. Option D is correct in this. Next. What is the maximum? 55.125 amperes we get. Okay. This is the maximum allowable current. From the given options, option D will be the correct one. Clear? Next question. See this. There are additional losses that arise from non-uniform current distribution in the conductors. Okay, and the core losses generated in the iron due to distortion of magnetic flux. So actually we have one concept in transformers, that is one of the loss is stray losses. What is the stray loss? So we have iron loss which takes place in transformer core and copper loss which takes place in winding. But we have iron stray load loss, if you remember. So where this iron stray load loss will take place? It will take place in transformer tank, because tank also made up of iron. So definitely leakage flux will be there in every transformer. Whenever this leakage flux links are connected with the tank, so there is some currents, circulating currents, which causes some iron stray load loss. Okay, so these are all due to distortion of flux. And non-uniform distribution of current will cause copper stray load loss. So totally we call this is a stray load loss simply. Okay, so it is not steel losses, or it is not frictional losses, or it is not windage losses. So directly also you can answer from options, it is stray load losses. Clear? Next question. See the question. If the magnetic core has a constant permeability by making air as medium, okay, for a coil current and the resultant flux linkage, then from the given option which is satisfying. So here if you observe given air medium, due to this air medium, is there any saturation of this core? No. No saturation concept. So whenever there is no saturation, always energy is equal to co-energy. But during unsaturation condition, suppose iron core is there, definitely it will saturate. So at that time these relations will change, energy and co-energy. But here as it is air medium given, due to this no saturation we have, as there is no saturation, the energy and co-energy both are equal. Okay, from given options, which one is there? Yes, first one. The energy and co-energy are equal. Okay, next question. See this. The structure of DC commutator machine is generally designed dash. So generally DC machine, so everyone knows. That's why in every stage of construction, whether it is DC machine or transformer or any synchronous machine, anything, so I said everything is important for engineering service. So here direct constructional details. If you have in DC machine, where is the poles? Stator. And where is the armature? Rotor. And what type of poles we are using? Projected poles, also called salient poles. So in the stator we have salient pole, but rotor is just round shape, that is not having any salient type. So here non-salient stator, salient rotor, this is wrong. Salient stator, non-salient rotor. Non-salient means cylindrical structure only. Okay, so option B is correct. Stator is having salient poles, projected poles, no? That's why that is salient stator and non-salient rotor. Okay, next. See this. The steady state external performance characteristics of a DC generator. So what is the external characteristics of DC generator we draw? So we have mainly like OCC, internal, external. External characteristics generally we draw between terminal voltage versus load current, V versus IL. Now let's check the options. Terminal voltage and load current at constant speed. Okay, option D is correct in this. Next question. See this. So it looks like a very big numericals, but if you understand the question and observe the options, you no need to solve it up. No need of any calculators. Simply you can do this. Read the question. A 250 volt 50 kilowatt short shunt compound DC generator has the following data. Short shunt compound connected it is. So draw the figure and put this data given. Now in this given armature resistance, series field resistance, shunt field resistance, and also breast drop 2 volts. Okay, what is the value of total current supplied by generator? So if you take the short shunt compound generator figure, it will be like this. Shunt compound. Okay, now observe here. So whatever the voltage rating is 250 volts. power rating given 50 kilowatts rated power output, and from this you can find what is the load current. Calculate load current, power divided by voltage. So 50k by 250 will give 200 amperes. This is the load current or line current, and this is our armature current. Total current supplied by armature is this. This is the field current. Okay. Now here we need to find IA, current supplied by this generator, total current, that is nothing but IA. Okay, or if you observe options once, generally shunt field current is very small value and IA is almost equal to IL only, and check the options once. Maybe the numerical having big values, but if you observe the options once, so if it is 200, IA will be little more than that. So if you observe options, it is not 0.2, it is not 2, it is not 2K, not 2000 also. Okay, so it is nearly 0.2 kilo amperes. And if you want to find exactly IA value, you need to find this node voltage here. Let us consider this is some Vx, this node voltage. And what is the series field resistance? 0.05 it is. Series field resistance is 0.05. If you calculate the value of Vx, we get 250 plus, and the current through this is IL only. Okay, what is that? 200 into 0.05. 200 into 0.05. So we get around 260 volts. This is our Vx. Okay. Now once you know this voltage, you can find ISH. So RSH value also there. What is the value of RSH? 130. Then ISH equals to 260 by 130. So this is 2 amperes. Then what is the value of IA? Sum of these two. 200 plus 2, nothing but 202 amperes. Okay. This is the total current from the armature. Okay. And if you observe the option, we don't have that 202 exactly. So we can consider 0.2 kilo amperes it is. Okay. Next question. In generating mode, an induction machine operates as generator. So induction machine can operate as generator and motor both. Okay. With a shaft speed which is greater than the synchronous speed. So shaft speed is nothing but motor speed, N. It is greater than synchronous speed. Okay. That is nothing but induction generator principle only. So in an induction generator, what is the slip value always? Negative. The value of slip for induction generator is negative, not equal to 0 and less than 0 it is. So from these given options, it is less than 0. Slip is less than 0. Option D is correct, because according to equation S equal to what? Ns minus N by Ns. Okay. If N is greater than Ns, we get negative slip. Okay. Next question. A 3-phase 60 Hz 25 HP star connected induction motor operates at a shaft speed of 1800 rpm at no load and 1650 rpm at full load. Okay. The number of poles of the motor. So easy question. Number of poles. Just by guessing you can answer this. How many poles? So definitely poles is not like 3.33, 6.66. And if it is 2 pole for 60 Hz, for 50 Hz itself it is 3000 rpm. But for 60 it is more than that. Definitely it is not correct. So 4. Or if you take randomly Ns is 120 60 by 4, we get the synchronous speed here is 1800 rpm. Okay. And given here it is rotating at no load condition 1800 rpm. But it is not exactly, almost near to that it will rotate. Little less than that. That's why no load speed is this. Generally under full load we know it will reduce a little bit. So 1650 given. So number of poles for this question is 4. Option C is correct. Next question. See this question. So question is looks very lengthy here, but ultimately we need to find in this question synchronous reactance per phase. That's it. First read the question quickly. A 3-phase 13.2 kilovolt 60 Hz 50 MVA star connected cylindrical rotor synchronous generator, armature reactance nothing but XA given. How much? XA 2.19 ohm per phase, and the leakage reactance is 0.137 times of armature reactance. So leakage reactance is 0.137 times of this one, 2.19. Okay. Now armature resistance is neglected. Assume that generator delivers full load current at the rated voltage at 0.8 lagging power factor, synchronous reactance. So very well known. What is the synchronous reactance? XL plus XA. So add these two here, 2.19 and 0.137 into 2.19. So you will get nearly it is 2.49 ohm per phase. Okay, direct question. So no need of any calculation from these power relations. 2.49 ohms, option D here. Okay, next question. For the commutated DC machine stator, it has riveted poles. So generally poles are riveted only. So in construction we know that poles are generally riveted to stator or yoke. Okay, and the ends of the poles are called ends of the pole. So from the given options, pole shoe, pole face, pole arc, pole gap. So it is not pole gap. Generally we called every field pole is having two parts, pole core and pole shoe. Pole shoe, and sometimes we also call it is a pole face also. Okay, but generally we have to consider it is as mainly pole shoe. Okay, we can also call pole face, but generally the first preference is for pole shoe only. Okay, next question. The following characteristics are drawn for salient pole synchronous motor. So if you observe, for salient pole, whether it is alternator, generator or motor, we have two powers, electromagnetic power and reluctance power. Electromagnetic power will develop electromagnetic torque. Similarly, reluctance power will develop reluctance torque. So here they given it is a torque relation. Electromagnetic power is having maximum value at 90 degrees. So electromagnetic torque also maximum, it is maximum at a load angle of 90 degrees. Okay, just like electromagnetic power, but reluctance power maximum at what angle? 45 degrees. But here question is for salient pole synchronous motor, curve B denotes dash. Curve B, what is curve B here? This one. So it is having maximum angle at 90 degrees. So that's why curve B is nothing but electromagnetic power relation, or it is producing electromagnetic torque. Curve B is electromagnetic torque. From option B is correct. Okay. So these are the some questions we got from electrical machines totally. So almost every question is very easy. There is no difficulty level in this. Okay. So take a short break. After that, next subject will continue. Okay.
Friends, I am Dr. Sudarshan Reddy, Control System Faculty for Electrical Engineering students, and let us see the solutions for ESE 2022 paper. The fourth question, which one of the following statements is correct regarding lead lag compensation? We know that major lag improves steady state performance, lead improves transient performance. Knowing that, this question can easily be answered. Look at the first one, the lag compensator improves the steady state performance of the system. Enough. That is the right statement. Hence, we need not go to second, third, fourth choices. That is B, C, D options, we don't need to look at it. Because first one we are 100% sure that lag improves steady state performance. Okay, therefore, what is the answer? Answer is A. A. Now, 5th, 6th, 7th and 8th questions, my friend Ganeshwar Rao is going to take. Please come, Ganeshwar Rao.
Yes, sir. Now, dear students, I am Jnaneshwar. We'll observe the remaining questions. Now, yes, 5th question, dear. Now read it. Consider the following statement for the phase margin. First statement is directly definition of the phase margin. This is the directly statement is given directly definition of the phase margin. So phase margin is defined as the amount of additional phase. So no doubt this the first statement is correct only, dear. Now the phase margin is always positive for stable feedback system. Now we know, dear students, now for stable system here, now for stable system both gain margin and phase margin both are positive. Gain margin and phase margin both are positive for stable system, dear. So this is for stable system. For stable system both gain margin, phase margin positive. So N statement 2 also correct. Phase margin is always positive for stable feedback system. Phase margin is always negative for the stable system is wrong statement here. So obviously 1 and 2 are correct. 1 and 2 are correct means option A is perfect answer. Option A is perfect answer. Now this question. Next we will look at one more question. Consider the following statements for a minimum and non-minimum phase system. Now minimum and non-minimum phase system. Here non-minimum phase system have poles and zeros in the right half of a plane for the trans function. Now minimum phase system have no poles or no zeros in the right half of a plane for their trans function. The modulus of this phase response. No doubt, dear, for the definition of the non-minimum phase system, this is correct only. Non-minimum phase system definition, that is correct only. Minimum phase system may have no poles or zeros in the right half of plane. That statement also correct, dear. Now coming to the third statement, the modulus of phase response for non-minimum phase system is larger than the minimum phase system. Now we know what is the statement here. For third statement I am explaining. Now we know phase of non-minimum phase system equal to phase of non-minimum phase system equal to phase of minimum phase system plus alpha system, dear. Alpha system. So obviously by the addition of minimum plus alphas we are getting non-minimum. Hence non-minimum phase system, here third statement, non-minimum phase system is greater than the minimum phase system. So obviously third statement also correct, dear. Third statement also correct. So all statements are correct here. All statements are correct. Which of the above statements are correct here? So 1, 2, okay. Now, okay, dear, 1, 2, 3 are correct answer here. Now, next we will look at one more question, dear. Consider the system is described with the state space related controllability and observability. Now, for the controllability, dear, we know MC equal to, this is a controllability. C suffix indicates controllability. Now we know this one BAB, dear. Now, if you find the determinant of the MC, if you find, now this is we are getting not equal, dear. Not equal means hence the system is controllable. Now calculate these values B product of AB, hence it is a controllable only, dear. We are getting not equal to 0. So controllable. Now similarly we can solve this one observability M suffix O. The formula is C transpose A transpose C transpose, dear. Now if we calculate this one, this is also we are getting not equal to 0 by calculation. We are getting not equal to 0, and this is not okay, observable only, observable. So the system is both controllable and observable. So the option, the system is controllable and observable. Now option C is correct. The system is controllable and observable both. Now, okay dear. Next, we'll observe one more question. On the state space, there are 2 questions here, 4 marks. Now, yeah, what is a state transition matrix dear? Generally, we will discuss in the classroom regularly, every year repeats this one, state transition matrix. Now, we were discussing in the classroom also, in the deep learning program also, asked this question here. Now, state transition matrix, actually formula for the state transition matrix, we have the, if you use the formula, it takes time. Simple dear, your state transition matrix equal to, what is the state transition matrix T equal to? A T equal to 0, a T equal to 0, now we'll get the identity matrix. Wow, nice. Now, substitute the values here, T equal to 0 here. T equal to 0, e power 0, 1, 1 minus 1, 0. So we are getting the 0 element. Hence, this option A is wrong. No need to check all the, okay, remaining, okay, first subject, first year fail. So no need to check these values. Now next dear, here, now e power 0, 2 minus 1, there is chance. Now here 0, 0. But here observe, now, okay, e power 0 plus 2. Yes, identity matrix. We are getting identity matrix. No doubt option B. For satisfaction point of, I am checking remaining options also. Here 2 minus 1, yes. Now 1 minus 1, 0. 1 minus 0. Now here again you are getting 2 minus e power 0. Yes dear, 2, 1 minus 0. Okay, 1 minus 0, 1. Now this is 0. Yes dear, 1, 0. This 0. Plus 1. Yeah, fine. Now this is state transition matrix by the, yeah, this is a 0 you are getting. Hence option D is wrong. Option D is wrong. Yeah, fine. Now, okay, let us, this is a 1, 0. So state transition matrix by the options. Now, yes, let us, these options. Yes, dear student, this is option B by mistakenly, okay, by mistakenly dear. This option B is copied as it is. Actually, this is a C option here, C option. Here there is no 2 dear, okay, by mistakenly printed here. So minus 1 plus 1, 0 dear. So hence option C is also wrong. So by mistakenly B we copied here, okay, here we get e power minus t plus e power minus t. This is also wrong dear. No doubt by using this formula, simply use this formula dear. Use this formula, state transition matrix T equal to 0, identity matrix. Now, yes, next questions is my Guruji will teach, okay, fine, comes.
Friends, welcome back. And look at that. In the system shown in figure below, numerical values for k, b, m, x, all that is given. What is asked here? What is the frequency observed in the vibration if displacement x measured from, okay, position is so and so. Displacement is given, asking the frequency observed. What is the frequency observed? Frequency observed, dear friends, it is omega d, damped frequency. It is omega n, we know that, it's well known, 1 minus zeta square. 1 minus zeta square. For this mass damping system, we can write the transfer function. Transfer function, if you write, what is the transfer function? 1 by ms square plus bs plus k we are going to get. This is the transfer function, dear friends. Transfer function of a mass spring damping system. Mass spring damping system transfer function. And from this, it's very clear that omega n, compare, the characteristic equation becomes divided by m, therefore s square plus b by m, what we get here? B by m and k by m. Now it's a regular problem. Okay, this becomes 1 by m. This becomes 1 by m. Now omega n is square root of k by m. 2 zeta omega n is b by m. 2 zeta omega n is b by m. Therefore, making use of those relations, what is that? Omega n, dear friends, it is square root of k by m. Substitute the given values here. And 2 zeta omega n is P by M. Okay, where B value is given, mass is given here, B value is given, and K value is also is given. All values are known. Substitute here, we will get omega n and zeta, and from that omega d damped frequency we are going to get 9.95. It is so simple to do. It's a regular problem. It's not at all difficult to solve this. And let us move to the next one. A feedback control system is shown in the figure. What is the value of K for unit ramp input so that the system will have a damping ratio of 0.5? Dear friends, it is not required whichever input it is, we can write the characteristic equation, compare with the standard second order system. From that what we get? As usual. So what is the characteristic equation? We can write the characteristic equation here. The characteristic equation is equal to 1 plus GSHS is equal to 0. 1 plus K by S into S plus 5 into 0.2, that is H, is equal to 0. Write the characteristic equation, compare. So therefore what we get here? S square plus 5s plus 0.2k is equal to 0. This is omega n square, this is 2 zeta omega n. Substitute the given value of zeta is equal to 0.5. From that we are going to get k is equal to 125, my dear friends, 125. It's a regular problem. Actually s square plus 2 zeta omega n s plus omega n square 0. It's normal. And next one, consider the following network. By the given data, it is very clear for what values of T1, T2, it is a lag network or lead network is asking. That means for lead, 0 is dominant, 0 is nearer. And this is pole. This becomes lead, 1 by T2, and this is 1 by T1. Therefore, if T1 is greater than T2, then the network, okay, what it becomes? T1 is less than T2, the network is a, first one is T1 is greater than T2, it becomes lead network. What is the second option? T1 is less than T2, then the network becomes a lag. For lag it is like this, dear friends. Pole is dominant, minus 1 by T2. And this 0 is far, like this. So it's very clear from this, option C is the right option. Option C is the right one. And let us move on to the next one. This is a little bit, for students, it is a little bit confusing one. But there is absolutely no confusion, my dear friends, because look at that. What is this? Actually dominant. Dominant poles are what? Near poles. Nearer to the imaginary axis. The poles, whichever poles nearer to the imaginary axis are called as dominant poles. How do you find the dominant poles? Look at that. This is easy to find from the root-lossy diagram. Students need not draw the root-lossy diagram. The design of a control system using the root-lossy diagram, one must know. To my knowledge, if I ask my students without a pen paper, my dear friends, without a pen paper, my students will answer this. I am 200% sure if they listen our lecture, ACE Engineering College lecture, they are going to answer within no time, without pen paper, because it's too complex to do it. You think, how without pen paper? There is a pole over here, minus 1 pole is given, and one more pole is given at minus 8. Minus 8. Friends, if a 0, A is a 0, 0 is taken 0.6, 1.4, 1.2 like this, and this is a pole. Here, what is sigma, dear friends? Sigma is like this. Sigma means centroid. Centroid is 0, minus 1, minus 8, minus A divided by poles minus zeros. That becomes 2. That becomes 2. It is so simple. If A is greater, centroid will be nearer to the imaginary axis. Centroid is nearer to the imaginary axis. Therefore, which one will be having nearer imaginary axis centroid? Definitely if you select 2.8 A, that means near this particular one, root lossy diagram moves like this. If you draw the root lossy diagram, my dear friends, it moves like this. There is a 0 over here, minus 2.8, minus 2.8, and centroid around 3.1, something like that we get it. See this, for these two almost centroid is same and the design is almost same. And this is ignored, completely ignored. The dominant poles become far poles. Dominant poles is never complex poles. The complex poles are far poles. The zeta damping is decided by omega and decided by complex conjugate poles. Therefore, complex conjugate poles very nearer to the imaginary axis when you do 2.8, the root lossy diagram nearly, it depends upon the breakpoint. It may be like this, or there is a root lossy diagram like this. Therefore, or it may be like this. It depends upon the poles. Okay, it depends upon the breakpoint. But anyhow, centroid is very nearer to the imaginary axis. Therefore, the quite possible answer and the exact answer is 2.8. One can check, okay, outside using the calci, you can check and verify these things. Okay, friends, 13th one. It's also so simple to solve. Nyquist stability criteria states that minus 1 J0 critical point should not be enclosed. For example, minus 1 if you take here, minus 1, because this is k by 2 radius, diameter becomes minus k. This is minus k, dear friends. This particular point is minus k. That particular point is minus k. Therefore, this is minus 1 I have taken here. And here, this is the enclosure region. This outside region is enclosure region. That means, okay, if you look at the arrow mark, if you travel along that, right side of the path is said to be enclosed. Therefore, minus 1 is enclosed, system is unstable. That means k less than 1, it is unstable. And if you take k greater than 1, if minus 1 is here, k is outside, system is a stable system. Because it is not enclosed. And k is equal to 1, definitely it is a marginally stable. Critically stable we say, limitedly stable or just stable. Therefore, answer is quite obvious, it is C. In the feedback control system shown in figure DS, DS is the step disturbance input, RS is the regular input, and CS is the output. Error is always found here. And what is asked here? In the feedback control system shown in figure, the steady state error component due to step disturbance. That means R of S is set to 0. R of S is set to 0. So what is our procedure? This error due to D of S should be calculated. My students will tell without pen paper this as well. How? Whatever component generally is here, reciprocal of that is the answer, error answer. 1 by 10 is the answer. Because from here, this is positive is there. What is the forward path up to this? It's minus. Therefore, minus 1 by 10 will be the answer. That means it is minus 0.1. How it is? It's so simple. One must use Mason's gain formula, my dear friends, ES by DS with RS set to 0. RS set to 0. We are going to get the transfer function. So simple. This I will solve. So transfer function forward path is 1 by S into S plus 40. So here to here, there is a negative symbol, minus divided by, and this is loop gain. Loop gain is what? 10 by S into S plus 40 you get it. S plus 40 we are going to get. And then this is ES by DS. ES divided by DS. And what is the steady state error? Steady state error, dear friends, it is limit S tends to 0, limit S tends to 0, S into E of S, just substitute, we are going to get minus 1 upon 10, that is minus 0.1, that's all. All these control system 12 questions, to my knowledge, less than 12 minutes you got to do. For me to explain it is not even took 5 minutes. That means definitely within 12 minutes you can solve it. Thank you.
Hello friends, sorry for the delay. From signals this year we got 13 questions. All are almost very simple models. This is a standard formula which we are learning in the class. What is the question? Find the jet transform of unit step sequence. U of n. U of n standard relation is what? 1 by 1 minus z inverse. Because it is a right-sided sequence with ROC mod z greater than 1 or z by z minus 1. Straightforward question. Very simple formula. The other question asked is consider the following statement about quarter wave symmetry. Quarter wave symmetry meaning is what? 1 quarter period, 0 to t by 4 range of a periodic function. It is stated a periodic function possesses a quarter wave symmetry if it has either odd or even symmetry, it has half wave symmetry. Very clearly we studied a signal that exhibits even plus half wave or odd plus half wave. For your understanding, one signal roughly I am sketching. For your understanding, with certain period, this has odd plus half wave, even a signal has even plus half wave, 100% they obey quarter wave symmetry. According to the symmetry condition, we are integrating for 1/4 of the period. So both are valid statements. Either odd or even symmetry it can have. Of course, apart from that, it should obey half wave symmetry also. Straightforward. This is from DTFT, discrete time Fourier transform. Positive negative side impulse are given for a period of 2 pi. Of course, they go on repeating because we know discrete in one domain will cause periodicity in the other domain. Try to get the inverse. So, the Fourier transform of 1 we know as a 2 pi del omega. But because they are shifted impulses, 1 into e power j ohm naught n will have 2 pi del of ohm minus ohm naught, frequent shifting property. Write the given spectrum for the range. Within the range, periodic range, minus j by 2 del of ohm plus ohm 1 plus j by 2 del of. Based on the standard formula, find out the inverse. Small adjustment, e power j theta minus e power minus j theta by 2j is what? Sign term. But in the options, he has missed minus sign. So, because it is ESE, certain mistakes will be there. We should feel option D is correct, but in the strict sense, it is wrong. Minus sign is missed. Extra minus sign also we will get in the problem. Straightforward model based on property. Here, this year ESE examiner, what he has done is, he has given the choice to prepare a question on your own, because data is like that. What is the solution for a periodic signal X is shown in figure? What solution? According to the options, we should feel that he is expecting what from us? Fourier transform. He is expecting Fourier transform. This is the given graph. This is the given graph. Just to find out the slopes. Here negative slope. Here also we have negative slope. Easy way to solve. Convert that ramp to constant type. When you differentiate this part or this segment, both segments will create a rectangle from minus T1 to T1. At origin we have a jump. At origin we have a jump. So that will create positive jump. That will create extra what? Negative impulse. So x dash t can be written as rectangle standard form. We are habituated with the negative amplitude minus rect t by T1. Extra impulse of weight 2T1. What is the standard rectangle Fourier transform? SAP function or sinc function. Write the spectrum. Extra j omega division we have to perform here by expanding that SAP function also. Normal SAP function expansion is sin x by x. After doing all that mathematics, you can feel option C, but examiner has given you prepare a question on your own. According to the given options, we should feel that it is asked for continuous time Fourier transform. Let us see the next model. Slightly lengthy question. Slightly lengthy. This is a habituated question. Those who have attended our classes regularly. Ideal low pass filter, standard formula. Ideal low pass filter. When you take rectangle from minus omega c to omega c, what is the answer we are writing? Of course, digital filter is limited for the range sin omega cn by pi n. Sin omega Cn by pi n. That is given with ohm symbol here, sir. So, for this you are writing what? Sin Wn by pi n. But he wants the answer in sync pulse form. What is sync expansion? Sin pi x by pi x. Make the required adjustments here. How to write this? Normally, if I adjust extra w, first it can be converted to shape function as sin x by x. Sin wn by wn can be written as what? Sin wn by wn can be written as SA of wn. How it is converted to sync pulse? W by pi sync of wn by pi. So, based on that, it is indicating which is the correct option. Normally, we are writing in shape function to sync function conversion is what? Sin pi x by pi x. Habituated model in the class. So many models we solved on that regular model. Straightforward question only. So, from DTFT, 2 questions were asked this year. This is our duality property. E power minus t ut decaying exponential has spectrum of 1 by 1 plus j omega. Now it is given as what? 1 by 1 plus jt. Applied duality. What is duality? Convert spectrum domain to time domain. Time domain is converted to frequency domain. So in this expression, omega replaced as t, this side 2 pi into, in our signal expression, t place what we are substituting? Minus omega. Minus, of course it is simplified as which expression? Very clearly from the given options. So one is standard formula, application of duality for that. Another model, 2 questions from DTFT, 2 questions from CTFT, continuous time Fourier transform. One of the signal is given as a rectangle, other one is given in impulse form. When you do convolution of these two, we are getting output. Output is nothing but xt convolved, h of t. In that process, as one of the signal is impulse, which property we are using? Convolution property of impulse. X of t minus t naught. So just convolve xt expression with this, because options are available in which form? X of t form only. So what is x of t convolved del of t plus 1? Straight answer, x of t plus 1. What is xt convolved 2 into del of t plus 2? 2 into x of. So based on convolution property of impulse, basics, it is concentrated. X of t plus 1 plus 2 into x of t plus 2. Very simple model. Un jet transform is our first question. Now see, a power n un. Normally, a power n un standard formula is what, sir? 1 by 1 minus a z inverse with mod z greater than mod a. Now it is left shifted or right shifted in the given term? Left shifted. What is shifting property in z domain? Z power minus n naught into. So in the given question, what is that n naught value? A power n plus 1 u of n plus 1 means what is n naught value? Minus 1 or not? So the original z transform extra multiplied by what? Z power minus n naught times 1 minus with mod z greater than mod a. Maybe our fellows have typed that as alpha symbol. Treat that as a, sir. Treat that as a. So which is the valid option there? Very clearly, first option is correct. Which one of the following statement is not correct for convolution? Not correct, incorrect statement. The convolution of even and odd function is odd. We know it. It is same as product concept. Same as product. Even convolved odd is odd. Normally even signal multiplied by odd signal is also odd signal. The convolution of odd and even function is odd function, correct. Convolution of two odd functions is even, that is also true. Convolution of two odd functions is even, that is also true. What is the third statement given? Convolution of two even functions is even, 100% true. Even convolved even is. So, which is the last statement? No need to check. The convolution of two odd functions is odd. Odd convolved by odd is even. Why it is wrong? What is the second statement made? Convolution of two odd functions is even function. Very clearly we checked it. Very clearly. So for this question, because it is asked which of the following statement is not correct for convolution, last one is convolution of two odd functions is odd function, which is a wrong statement. What is the sampling frequency of the signal sync square? Sync square means we are sketching the spectrum as a triangle, which covers from minus 400 pi to 400 pi. You know sync x is sin pi x by pi x. For that square is given. This is the highest frequency. Omega max is 400 pi. That means f max is 200 Hz. Sampling frequency means he is expecting the Nyquist rate, minimum sampling rate, 2 times f max. 2 into 200 is the answer. 2 into 200. Another straightforward question. Sync square expansion is sin pi x by pi x whole square, a triangular spectrum. This is in omega domain. I have taken Hertz scale, highest frequency 200, because this is 2 pi into 200. We got sampling rate 2 times Fm. 2 times Fm. What is the final value of this function? Very funny question. It is a damped sinusoidal wave. Decaying exponential multiplied by, roughly the graph is like this. As t tends to infinity, what is the answer, sir? Everyone can recognize. Answer 0. Suppose you did not get the idea. Apply final value theorem of Laplace. Limit s tends to 0, s into f of s, where we have to take standard Laplace of e power minus 2t sin phi t ut. Predefined relations, e power minus at sin bt ut, v by s plus a whole square plus v square. That way also you can solve. V by s plus a whole square plus. So what will happen? 5s by s plus 2 whole square plus 5 square. Directly s plus 0, 0 by something is what? 0. No need to waste your time by applying the theorem. 150 questions. Draw the graph. At infinite time, amplitude is approaching to what? 0. Suppose you did not get the idea, Laplace. Final value theorem of Laplace transform. This is another easy question asked. By giving xn as alpha power n un, what is g of n? You can write g of n as directly substitute it. Alpha power n un minus alpha into alpha power n minus 1. Alpha into alpha inverse becomes 1. Alpha into alpha with common multiplier un minus u of n minus 1. Everyone knows the first difference of step sequence is impulse. Last step, product property of impulse. Impulse exists at 0, directly n place. So what is g of n, sir, after simplification? What is g of n answer? Del n. First difference of step sequence is del n. Here which property we applied? Product property of impulse. Alpha power 0 into del n. Final simple answer is del of n. Very simple question. This is one beautiful question. How many minimum number of samples are required to exactly describe two sinusoids? Sum of two sinusoids. See, fundamental frequency GCD of 6 pi and 8 pi, that becomes 2 pi. So, you can say that this is third harmonic, 3 into 2 pi, this is fourth harmonic. To represent a sine wave, we need minimum 2 samples per second. To represent a sine wave, we need sine or cosine? We need 2 samples per second minimum. So here, first signal has 3 cycles, second signal has 4 cycles. 3 twos are 6, 4 twos are 8. But what is the question asked? How many minimum number of samples required? So which is having more number of cycles? 4 cycles is the highest number of cycles. 4 cycles of sine wave. So 4 cycles requires 4 into 2, that is 8 samples per second. So maximum that fellow has concentrated on basics. This is one of the good question. One question statement is not given for us in CTFT that we have to solve. Total 13 questions we got from signals. All are simple models. The last question we require some logic for understanding. Next, another faculty will come, analog circuits. Dr. Satyanarayana sir will take care of analog circuits.
వాయిస్ చెక్ చేసుకో. Good evening, students. So in the total analog, the 15 questions came, that is totally that analog plus basic electrical engineering. All questions are very simple. So coming to the first question, the statement one is, if the gain margin is negative, this gives the decibel rise in open loop gain, which is theoretically permissible without oscillation. So theoretically permissible without oscillations, in order to that gain margin must be positive, but here given negative. So this is the wrong statement. So this statement is wrong. Coming to the second statement, for a multi-stage amplifier, if the loop gain mod A beta is unity when the phase shift is 180 degrees, then the closed loop amplifier will oscillate. So in order to oscillate, the loop gain must be, what is given? Unity. And the phase shift is 180 degrees. And the amplifier will oscillate. So this statement is correct. So the statement 1 is wrong and the statement 2 is correct. So the option D is the correct one. First statement is false and second statement is wrong. Coming to the next slide. Next question. The statement 1. When negative feedback is applied to an ideal amplifier, the differential input voltage is 0. So the differential input voltage Vd is 0 when negative feedback is applied. In the second statement, there is no current flow into either input terminals of ideal op-amp. So when negative feedback is applied, differential voltage is 0. This is the correct statement. And the current entering into the op-amp terminals is 0. This is also correct statement. But the statement 2 is not correct explanation of the statement 1. Why? So the differential voltage is 0 because of open loop gain and the no current entering into the op-amp terminal because of high input impedance of the device. That's why the statement 2 explanation is not correct for statement 1. Now the option B is the correct for this question. Coming to the next problem. Next question. The statement 1. When a carrier is generated by a crystal oscillator, the frequency is fixed by the crystal. So whenever the carrier is generated by the crystal oscillator, the frequency of oscillations is 1 by 2 pi root LC. For a fixed crystal, the L and C values are fixed constant value for a given crystal. So as L and C are fixed, so the frequency of oscillations is fixed by the crystal. The equivalent circuit of a crystal is an LCR circuit with both series and parallel resonant circuit. So as it is a combination of LCR, that resonant series frequency will be there, parallel frequency. But as L and C are fixed, so this generates the fixed oscillation. So the statement 2 is correct explanation of the statement 1. So the option A is the correct one. Both the statements are correct, but statement 2 is the correct explanation of the statement 1. Then coming to the next question. A transistor as beta is equal to 105. The collector current is 840 microamperes. What will be the value of base current? So your IC is equal to beta times of IB. So as given IC is given, beta is given. Now the value of base current is IC by beta. So the value of IC is given 840 microamperes. This is 105. So this becomes 8 microamperes. So the base current of the transistor for the given data is 8 microamperes. It is very simple question. Now coming to the next question. What is the power gain of a transistor amplifier if its current gain is 40 and voltage gain is 25? So the power gain is the product of voltage gain and current gain. So the power gain is the voltage gain and the current gain. Given that voltage gain as 25, current gain as 40, so the power gain you will get 1000. So option C is the correct one. Now coming to the next question. Which one of the following statement is not correct regarding common base amplifier? The output is the same phase as the input alternate signal. Means same phase means there is no phase shift between input and outputs. As the phase shift is 0 for common base amplifier, so the first statement, first option is correct only. It cannot operate at high frequency as compared to common emitter amplifier. First of all, this common base amplifier is a wideband amplifier because there is no Miller effect in this one, so whose bandwidth is very high. So as bandwidth is very high, this can be used as a wideband amplifier, so this can be used at higher frequencies. But what is given? Cannot operate. So this statement is wrong. Current gain of common base is less than unity. The impedance matching needed for cascading, because there is very large difference between input and output impedances. Input impedance is very low for common base and output impedance is high. So the option B is the correct, but it is a wrong statement. But what asked? Not correct statement. So option B is the correct one. Coming to the next question. When the quiescent point of the amplifier is biased just at the cutoff axis, so that only positive of the signal input is amplified and negative of the signal is cut off, it is referred to as, options are given, class AB, class A, class B and class C. Coming to your biasing. So this is your voltage, this is your current. On the voltage axis, so this point is cutoff point. So whenever it is on the cutoff axis, only the positive cycle only transmitted to the output terminal. So our conduction angle is only 180 degrees only. Whereas in the class AB, the conduction angle is 180 to 360, means that is just above the cutoff axis. In the class A, it is exactly middle of your DC load line, middle of the DC load line for class A. For class B, on the cutoff. For class C, it is the conduction angle is 0 to below 180 degrees only. So as it is given, only half of the cycle is transmitted, amplified. So this is class B amplification. Then coming to the next question, which one of the following is disadvantage of common emitter amplifier? Disadvantage. So it provides, options are, it provides good currents as well as good voltage gain. Current gain is more and voltage gain is more for common emitter amplifier. So this is correct statement only. It provides the maximum power gain, means current gain is more, voltage gain is more, definitely power gain also more for common emitter. It has a medium, both input and output impedances. For common emitter, the input impedance is moderate value, output impedance also moderate value. Its frequency response bandwidth is lower than the amplifiers of the other two configuration, means common base and common collector. So for common collector, bandwidth is more. For common base also more than your common emitter only. So the frequency response bandwidth is lower because of the Miller effect in the common emitter, its frequency response is limited. So this is the disadvantage of your common emitter amplifier. Coming to the next question, which one of the following consists of op-amp inverting mode, means that should provide the 180 degrees of phase shift and the network of RC net components. The op-amp being in inverting mode, it serves two purposes of amplifying and its outputs 180 degrees shifted in phase obtained. So this is RC network consists. RC network is either it is Wien bridge oscillator or a RC phase shift oscillator. So in Wien bridge oscillator, that op-amp must provide the 360 degrees of phase shift or 0 degrees of phase shift. That must be in non-inverting mode only. But in RC phase shift oscillator only, your op-amp is in the inverting mode. So option B is the correct one. So coming to the next problem, next question. Which one of the following statement is not correct? Again, not correct. Related to oscillators. Now in oscillators, the frequency of sinusoidal oscillator is determined by the condition that loop gain, phase shift, the total phase shift must be multiple of 2 pi n, where n is 0, 1, 2, 3 and so on. So here 0 is given. So theta must be 0. So this is correct statement only. The second one is, in every practical oscillator, the loop gain is slightly greater than 1. Means in practical oscillators, this must be 1.06 will be there, the loop gain. And the amplitude of the oscillations is limited by the onset of non-linearity. For that only it is set at 1.06 practically. So this is statement also correct. So option A and B are correct. Then the option C, the condition of unity loop gain A beta is equal to 1 is called Barkhasin criteria condition. So minus A beta is equal to 1 is called Barkhasin criteria condition or condition for oscillation of an oscillator. So that also correct. Now the option D, by default, as the first three options are correct, so you will get the fourth one only. The oscillations will be sustained if at the oscillator frequency, the magnitude of the product of transfer gain of the amplifier and the magnitude of the feedback factor. Magnitude of the feedback factor is beta. The transfer function of the gain of the amplifier is A beta. That A beta is less than 1. A beta is less than 1 is wrong statement. So for oscillations it is 1, means satisfies the Barkhasin criteria. Practically that must be slightly greater than 1 but not less than 1. So your option D is the correct one. Your not correct statement asked. So that's why D is the correct one. So coming to the next question. Following statement is not correct for a transistor. So the region at the center is always base region. So as your transistor, this is emitter, this is your base, this is your collector. Emitter is always heavily doped. Lightly doped. Collector is always moderately doped. Now the base region at the center, so base is always the middle region. So the option A is correct only. The emitter region is more heavily doped and the base region is very lightly doped. So this is also correct only. So the collector region is very lightly doped compared to the base region, but collector is somehow more doped compared to your base region. But, so this is the wrong one. The low power input can be converted to a large power outputs, so signal amplification, with the help of small piece of semiconductor without any hassles of preheating and handling of large heat dissipation. So this is also correct. So option here not correct asked. So that option C is the correct one for this. Then coming to the next question. For a certain of the reverse voltage in a transistor, the effective base width may reduce it to 0, resulting into the voltage breakdown. This phenomena is called. So in a transistor, whenever the reverse bias voltage across the collector junction increases, then what happened? The depletion region width increases, your base width reduces. As the reverse bias voltage goes on increases, your base width goes on reduces at some particular large voltage. What happened? The base width reduces to 0 and the breakdown of your transistor takes place. This total phenomena is called a reach-through process or punch-through process. It is a direct definition only. So this is punch through process or reach through process. So whenever the reverse bias voltage increases, at large reverse bias voltage, your base width reduced to 0 and breakdown occurs. That phenomena is called punch through process or reach through process. Coming to the next question. As n-type semiconductor specimen as a Hall coefficient. So Hall coefficient is given how much? 300 centimeter cube per coulomb. And its resistivity is given 0.1 ohm centimeter. Then electron mobility is, the electron mobility is, what is that? Sigma into RH, which is nothing but RH by rho. So 300 by 0.1, so it is 3000 centimeter square per volt second. So option C is the correct one. So direct question. Coming to the next question. In a PN junction diode, the reverse saturation current increases by 7.2% by a degree rise in junction temperature. So generally we'll speak about 7% only. Here exactly is given 7.2%. And gets, as the temperature increases in your PN junction diode, what happened? The minority carrier current passing through the junction increases. Temperature also increases. For every 1 degree rise in temperature, it is increased by 7%. For every 10 degrees rise in temperature, it becomes double. So doubled for every 10 degrees rise in temperature. So direct question, or to calculate that, your I02 is equal to I01 into 2 power T2 minus T1 by 10. Otherwise, if a rise in temperature of 10 is there, it becomes double only. So the option B is the correct one. Coming to the next question. Following is correct in the feedback circuit having 3 resistances and capacitances, 3 resistances and 3 capacitances elements with the condition as R1, R2, R3 is R bar and C1, C2, C3 as C bar for the phase shift oscillator. So it is given RC phase shift oscillator whose frequency of oscillations is 1 by 2 pi RC, means R dash C dash root. So this 1 by 2 pi root 6 value is 0.065 by, this is the frequency of oscillations. So the option A is the correct one. So all the questions are very simple only. Okay.
Hi, myself Krishna Reddy, Faculty Power Systems for ACE Engineering Academy. Now, let us try to find the solutions for some of the questions that are given from power system subject. Okay. First one, let us observe which one of the following is not the basic functional characteristic of protective relay. So, he is asking which is not a basic functional characteristic. So, if you observe reliability, reliability should be there, sensitivity should be there, and relay should operate with speed. Linearity is not the basic characteristic, okay. So, option is D, okay. Linearity is the answer for this question, okay. Chalo. Now, let us observe this question. In a system of 132 kV, line to ground capacitance is 0.01 microfarad, inductance is 4 Henry. What is the voltage appearing across the circuit breaker contacts if the instantaneous value of magnetizing current of 5 ampere is to be interrupted? So, what he is saying? So, if 5 ampere current is to be interrupted, what is the voltage that is to be appeared? Now, let us try to observe here. Okay. So, if you observe the network, so he has given the value of inductance as well as capacitance. We need to calculate the voltage across the circuit breaker contacts. That's what he is asking. Inductance given as what? 4 Henry. Capacitance given as 0.01 microfarad. Now, when the current through the inductor is how much that is to be interrupted is 5 amperes. So, 5 amperes. As it is not 0, there will be energy stored in the inductor in the form of electromagnetic field. Yes or no? Half Li square. So, this energy will be appearing as electrostatic energy in the capacitance, that is half CV square. So, whenever this capacitance is building up the energy, there will be voltage appeared across the breaker contacts. So, how do we calculate this prospective voltage here? So, if we equate this to half Li square equal to half CV square, so we will get the value of prospective voltage. V is equal to I root of L by C. Okay. So, what is the current that is to be interrupted here? 5 amperes of current, and inductance given in the question as how much? 4 Henry. Capacitance given as 0.01 microfarad. 0.01 microfarad, 10 power minus 6. So, here if you simplify this, you will be getting it as what? 100 kV. This is a straightforward question that we are frequently discussing in our classroom objective types, okay. So, option is C, 100 kV. Okay. So, let us go to next question. So, test does not come under the testing of circuit breaker. So, this question is based on what? Testing of circuit breaker. So, if you observe, we will not conduct any open circuit test on circuit breaker. So, option is straightforward. Open circuit test will not be conducted on circuit breaker. In a power system, the maximum power can be transferred from one end to other end when the reactance of the line is. What is the condition that must be satisfied? So, when x by r is equal to root 3, then you will get the maximum power transfer. Then x is equal to root 3 times of resistance. So, what is asking? Reactance of the line is. That's what he is asking to calculate here. So, that will be root 3 times of the resistance. Option A is the right answer. So, this question is also frequently discussed in our classroom. This is a basic question that we can directly answer. Okay. Chalo. Let us observe this question. A 50 Hz 4-pole turbo generator rated 30 MVA 13.2 kV has an inertia constant of 9 kilowatt second per kVA. What is the kinetic energy stored at synchronous speed? So, if you want to solve this problem, we need to know the relation for what? Inertia constant. So, how do you calculate the inertia constant? H. Inertia constant H is equal to stored kinetic energy by rating of the machine. Okay. So, kinetic energy is equal to what? Inertia constant into rating of the machine. Here inertia constant given as how much? 9. So 9. What is the rating of the machine? Given as what? 30 MVA. Okay, 3 9 is 27. 270. Okay, so if you observe the options, option C is the right answer. Okay. Now let us observe this question. Which one of the following is not the example for renewable energy? So which will not come under the renewable energy, not an example for renewable energy. Solar comes under renewable energy source. Wind comes under renewable energy source. Geothermal comes under renewable energy source. So nuclear will not come under the renewable energy source. So the option is nuclear. Okay. Thank you for giving me this opportunity. Now few more questions from power systems will be discussed by another faculty member.
Hello everybody, my name is DMV Prasad. I am discussing some of the questions of power systems here. Now coming to the question here, so the question asked on the positive sequence impedances. The question here, what is the positive sequence impedance component of 3 unequal impedances ZA, ZB and ZC? So actually this question has to be designed based on the voltages or currents. Why? Because the voltages and currents are always phase shifted by 120 degrees, but the impedance may not be. But they are thinking that the impedance is also phase shifted by 120 degrees. Based on that one, the options has been designed. So whenever the impedances are phase shifted by 120 degrees, we can give that the positive sequence impedance value ZA1 is equivalent to 1 by 3 times of ZA plus A times of ZB plus A square times of ZC. So like that we can give the answer, right? So that based on that one, so we can take, it will be 1 by 3 times of ZA plus A times of ZB plus A square times of ZC. So remember that here the impedances are assumed to be having 120 degrees phase shift. Is it clear? Now, so this is the next question. So it's one of the very easiest question directly asked on the type of the wiring. So we are having different types of wiring. So in which the conduit wiring is always having the highest advantages. So in most of the commercial and domestic buildings, so we are going for the conduit wiring. See here, which one of the following wiring system is commonly used for light or fan load in domestic and industrial or commercial applications. So in commercial and domestic applications, the most commonly used type of wiring is the conduit wiring. So that we can go for the conduit wiring. Is it clear? So conduit wiring is the most commonly used type of the wiring. And whereas in all the types of wirings, we can go with the PVC cables. PVC cables are preferred in all the types of the wirings, right? So this is the next question. So it's a straightforward question. Which one of the following is not an advantage of using bundled conductors? Remember, the usage of bundled conductors is giving more advantages for you. So whenever we are going for the usage of the bundled conductors, so the overall radius of the conductor will be increased. We can say that the GMR of the conductor will be increased. Whenever the GMR is increased, see here we are having the inductance formula where L is equivalent to 2 into 10 power minus 7 ln of GMD by GMR. GMD by GMR. So remember, whenever the bundled conductors are used, the GMR will be increased so that the inductance will be reduced. So whenever we are reducing the inductance, so that the reduction in the inductance is reducing the reactance. Now if you see the options, so they are given that there is a reduced surge impedance. If you go for the surge impedance, what is the surge impedance? Zs is equivalent to root of L by C. Root of L by C. So whenever L is decreased, automatically surge impedance will be reduced. Surge impedance will be reduced. But they are asking what is the not correct statement. So that option D is not the perfect answer we are going for. The statement is perfect only, but it's not the correct answer, I'm saying. Is it clear? And coming to the option C, see here, for constant power transfer, P is equivalent to V1 V2 divided by X into sine delta. For constant power transfer, we are having P is equivalent to V1 V2 divided by X into sine delta. So that to have power constant, whenever the reactance is reduced, so that the numerator should also be reduced to maintain the power constant. So to maintain the power constant, whenever X is reduced, the numerator should also be reduced. But what they have given? They have given it is increased voltage gradient. So whenever the bundled conductors are used, the voltage gradient should be reduced, but they are given that there will be an increased voltage gradient. Therefore, so this is the correct answer. This statement is wrong and it is correct for this question. And we are using bundled conductors preferably to reduce the corona losses as well as the radio interference in the system. We are preferring the bundled conductors in the system to reduce the corona losses as well as radio interference in the system. Is it clear? Therefore, the correct answer is option C. And coming to the next question, which one of the following is not a method of voltage control? So what are the methods of voltage control? So the methods of voltage control are by connecting the shunt capacitors, by connecting the shunt inductors or the reactors, and by using the booster transformers, by using the tap changing transformers, and by using the synchronous motor or synchronous condenser or synchronous phase modifier. So all these are the methods of the voltage control, right? But they have given that which is not the method. So that the series capacitor we are not at all using to control the voltage. The series capacitor may be used to improve the stability, but the series capacitor is not used for voltage control. Why? The series capacitor is introducing some synchronous resonance in the system. It is going to introduce some subsynchronous resonance in the system. So because of that one, so we are not going to prefer the series capacitor for the voltage control. Is it right? And coming to the next question, so this question is somewhat different. It's not a repeated question in the previous engineering service examinations. It's what we have to solve some equations for this one. Suppose here an inductance of 800 microhenry connects two sections of a transmission line, each having a surge impedance of 200 ohms. Now, a 500 kilovolts 2 microsecond rectangular surge travels along the line towards the inductance. So what is the maximum value of the transmitted wave? See here, there are two sections of the transmission line. So that I am taking the impedance of the transmission line as say Z. And in between we are having an inductor and there is one more section of the transmission line. Now here, what is the maximum voltage transmitted through the inductor? So that this question may be solved by using the network theory, so that we can take two inductors or two impedance of the transmission lines as 2Z and here it will be L. So what is the voltage transmitted through the inductance? See that if you calculate the voltage transmitted through the inductor, it will be V into 1 minus e power minus 2Z divided by L into the time constant. And we need to substitute the value of Z here, and we need to substitute the value of L here, and we need to substitute the value of tau. So that if you calculate that one, you will get V into 1 minus 1 by E. So that this value will be V into e power minus 1 by E. So that the perfect answer is option A. So that where V is 500 kilovolts. So that we can substitute here, it will be 500 into e power minus 1 by E kilovolts. Is it clear? And coming to the next question, see here, so the faults on power system are analyzed easily by using which theorem? See here, we are forming Z bus by using the Thevenin's theorem. So whenever we are calculating all the diagonal elements of Z bus by using Thevenin's theorem, so we are more using the Thevenin's theorem to solve the faults. And the Z bus is the most probable way to calculate the fault currents at each and every system. Is that right? So these are the questions we are having in the power system, and almost all the questions are very, very easy. So except the previous question, right? Thank you.
Hello everyone, how are you all? So myself, Professor Rajendra Gharse, I have done MTech from Indian Institute of Science, Bangalore, and I was the All India 7th ranker in the GATE examination. So now we are going to discuss the power electronics questions. So let us start. Which one of the following is the circuit symbol of P channel IGBT? So here they have given the P channel IGBT, and the options are here A, B, C and D. So strictly speaking, option A and option B, these are the MOSFET symbols, yes or no, right? This one is a N channel MOSFET, second one is a P channel MOSFET, right? So option A and B, these are the MOSFET symbols. Whereas we know IGBT is a combination of power MOSFET and a power BJT, yes or no, right? And here they have given the next two options C and D. Strictly speaking, here it should be collector and a emitter. There is a printing mistake in the examination. There is a printing mistake in the examination. Here it should be collector and here it should be emitter, collector emitter terminal. So, and here it is also collector and emitter terminal. So if you check here, yes, here both the arrows are inward. So it is a N channel IGBT and this is the P channel IGBT. They have asked for P channel IGBT symbol. So correct answer is option D, right? Option D is the correct answer. Next, the regenerative action does not take place in which type of triggering method to turn on the SCR? We know in the SCR triggering we are having the 5 different methods. Okay, so which method, yes, in which method the regenerative action does not take place, they have given, right? So here if you check thermal triggering, light triggering and gate triggering. In all these three actions, generally the regenerative action is taking place. Regenerative action means initially the current is like a leakage current, and after that, due to the added charge carriers, due to the generation of additional charge carriers, the current will go on increasing from leakage current to the high value. That is the regenerative action. That is the regenerative action, and that is taking place in option A, C and D. But whereas if you check in a high forward voltage triggering, what we are doing? We are maintaining a very high applied voltage across the SCR, so that the breakdown of the depletion layer across junction J2 takes place and our SCR turns on. So option B, in the option B, the regenerative action is not taking place. So correct answer is option B, right? Next, which one of the following is also known as resonant commutation? Okay, so they have asked which one of the following is known as a resonant commutation. So we know in a commutation technique we are having the 5 methods or 5 techniques, like a class A, B, C, D and E. Out of that, class E is nothing but the external pulse commutation, right? Class B is like your current commutation. Class C is again it is a type of the voltage commutation, and class D is also type of the voltage commutation. Okay, so class A is a resonant commutation. Class A is a resonant commutation. You recall class A commutation. In the class A commutation, we are having the RLC circuit, na? Right? And the requirement is this RLC element value should be such that circuit behaves as an underdamped circuit, and due to that we will be getting the current nature will be like a sinusoidal pulse, right? So correct option is option A, that is a class A commutation. Next, which one of the following is a current controlled device? Very simple question. Which one of the following is a current controlled device? So strictly speaking, here MOSFET, SIT, that is a static induction thyristor, and MCT, that is the MOS controlled thyristor. All these three are voltage controlled thyristors. All these are voltage controlled. So they have asked the current controlled. So GTO, we know na, GTO can be turned on by circulating the positive gate current and can be turned off by circulating the negative gate current. So GTO is a current controlled device, right? Next question. In line frequency, phase controlled converters and single quadrant step down switch mode DC to DC converters, the output current can become, so here they have given the options. So you can check here, in the step down switch mode DC to DC converter or in a rectifier, right? Line frequency phase controlled converters means it is like a rectifier. Okay, if we are having a light load, okay, if we are having a light load, so suppose we are having the load is inductive and it is having a light load, so that's why the current will be less, load current will be less. So if load current is less, what about the energy stored by the inductor? It is like half into Li square, na? So if current is less, definitely the energy stored by the inductor will be less. This will be less. So if energy stored by the inductor is less, definitely within a lesser time, within a shorter time, the inductor can release the energy. So there is a possibility of discontinuous conduction, right? Discontinuous conduction. So if you check the options, discontinuous at light loads on motor, this is the correct answer. Okay, next, separately excited DC motor is to be controlled from a 3-phase supply fed from controlled rectifier in only first quadrant. Which one of the following converters is used to serve the purpose? So they have given only first quadrant operation, right? Only first quadrant operation. First quadrant operation means what? Output voltage and output current should be always positive. Yes or no? Right? Now, which converter gives the output voltage always positive? We know it is a semi-converter. Yes or no? Right? We are having the full converter, semi-converter and dual converter. Dual converter gives the 4 quadrant operation. Semi converter only single quadrant operation, and full converter 2 quadrant operation, that is the first and the fourth quadrant, right? And they have asked the only first quadrant, means definitely the answer will be a semi converter. So correct option is option C. So very straightforward questions actually they have asked. Next, in case of squirrel cage induction motor using 3-phase bridge inverter, okay, so we are giving the output of 3-phase bridge voltage source inverter to the 3-phase squirrel cage induction motor. Which one of the following statements is correct for speed control? Okay, for speed control. Now here we are having the squirrel cage induction motor, output of the voltage source inverter. Here it is a DC input, here it is a 3-phase voltage source inverter. Here it is a VDC, or you can say VS also, doesn't matter. And at this side we are having a 3-phase induction motor. 3-phase induction motor, right? Now let us check the options. Yes, if frequency increases, then starting torque decreases with constant supply voltage. Means they have given the relation between frequency and the starting torque. Second, if frequency increases, then starting torque increases with a constant supply voltage. If frequency decreases, then starting torque decreases with a constant supply voltage. And if frequency decreases, then starting torque increases with a constant supply voltage. So here supply voltage is constant, means V is constant, that is like input to the motor is constant. Okay, so V is constant. V is a constant. Now if the voltage is constant, then how the starting torque of induction motor relates to the frequency? We know the starting torque of induction motor is inversely proportional to the cube of the frequency. Yes or no? Right? So starting torque is inversely proportional to the F cube, that is the cube of the frequency. The frequency is nothing but the output frequency of the inverter. Now here, so important to note, if frequency decreases, starting torque increases. Yes or no? Right? So you can check, if frequency decreases, starting torque increases, or we can say in another way, if frequency increases, starting torque decreases, right? Starting torque decreases. So if you check the options clearly, if frequency increases, then starting torque decreases, right? This one is one of the possible correct answer. Second, you can check, if frequency increases, starting torque increases. Frequency is increasing, starting torque is also increasing. So whether this will be the possible correct answer? No. Third one, if frequency decreases, then starting torque decreases. No, because both are inversely proportional. And the last option is, if frequency decreases, then starting torque increases, right? Frequency decreases, starting torque increases. So option A and D can be the possible answers, but we need to think in a practical way. Here the input supply voltage is a constant, yes or no? So if the supply voltage is constant, and we know generally the induction motors are designed in such a way that the operating point, okay, should be nearly at a rated flux density. We know now B max is proportional to V by F. Now if we are keeping the voltage constant, please listen it carefully. If the voltage is constant and if I decrease the frequency, if the voltage is keeping the voltage constant and if I decrease the frequency, voltage is constant and I am decreasing the frequency, the meaning is Bmax will increase. The means what? The motor will go into the deep saturation, and this is not allowed now in practical case, right? So please keep it in mind. Voltage constant, frequency decreased, your Bmax will increase, means motor will go into the deep saturation. So this is not a practical approach. Are you getting the point? So the correct answer is, by keeping the constant voltage, if we increase the frequency, then definitely your Bmax will decrease, right? That will be the possible answer, okay? Because by keeping the frequency constant, we cannot reduce, by keeping the voltage constant, we cannot reduce the frequency at all, right? So correct answer is frequency increases, and frequency increases means starting torque decreases. So if you check, if frequency increases, then starting torque decreases with a constant supply voltage, means correct answer is option A, right? Option D is not a correct answer. Okay, option A is the correct answer. Is this clear? We need to think in a practical way here, right? Next, while finding various factors of single phase diode rectifiers, the transformer utilization factor of half wave rectifier is, they have asked the transformer utilization factor, and the options are like 0.482, 0.572, 0.286 and 1.11. So here we are having a single phase half wave rectifier. Okay, so single phase half wave rectifier circuitry will be like this. We are using a transformer. And here we are having a half wave diode rectifier. Na? Let us consider load is resistive. Diode 1:1. Suppose this is a Vs. Okay. Now, what is the transformer utilization factor? We know TUF. Transformer utilization factor. It is equal to output DC power, that is a PDC, divided by volt ampere rating of transformer secondary. VA rating of transformer secondary. Rating of transformer secondary. Transformer secondary. Right? So in order to find TUF, transformer utilization factor, we need to find PDC and VA rating of transformer secondary. So what is the PDC? Yes, PDC, that is the output DC power. So output DC power, PDC, is equal to V0 average into I0 average. V0 average into I0 average. Right? Now what is the V0 average here? In this case, what is the V0 average? V0 means voltage across the load, and I0 is the current flowing through the load. So this is the single phase half wave rectifier. How will the waveform of V0 and I0? Yes, this is omega t 0. V0 waveform will be like this. 0 to pi, like this. 0 to pi, pi to 2 pi, 2 pi to 3 pi. Yes or no? And how will the waveform of I0? In phase with a V0. Here it is the waveform of the I0, right? Pi, 2 pi and 3 pi, correct? Now what is the V0 average in this case for this waveform? Yes, V0 average, you can simplify it, we'll be getting it is a Vm by pi. And what is I0 average? It is equal to Im by pi. Im by pi. So therefore PDC is equal to Vm into Im upon pi square. Vm into Im upon pi square. Right? Next, VA rating of transformer secondary. So here we are having the transformer secondary winding. So VA rating of transformer secondary means RMS value of transformer secondary voltage into RMS value of transformer secondary current. So what is the RMS value of transformer secondary voltage? It is equal to Vs only. Okay. So RMS transformer secondary voltage, it is equal to Vs means Vm by root 2. Vm by root 2. And what is the RMS value of transformer secondary current? This is RMS value. RMS value of transformer secondary current. Right? RMS value of transformer secondary current. So transformer current will be like your load current only. Yes or no? Right? Unless and until the current will flow into the load, the current will not flow into the transformer secondary even. Okay? So therefore RMS value of this waveform, it is a Im by 2. Im by 2. Right? So therefore you can check the TUF. Therefore TUF is equal to Vm into Im by pi square divided by, yes, transformer VA rating, which is equal to Vm by root 2 into Im by 2. So it is equal to Vm into Im upon 2 root 2. Here it is Vm Im will get cancelled out. So it is 2 root 2 by pi square. If you simplify it, we will be getting it as 0.286. 86. So correct option is option C. Okay, option C is the correct option. Next, which of the following motors are commonly used? Yes, which of the following motors are commonly used in power electronic systems? They have given synchronous motors, DC motors and DC motors with brushes. So if you check these three motors, the commonly used motors in a power electronic systems are DC motors and brushless DC motors, right? That is with brush and without brush. BLDC you might have heard. Okay, so second and third, these are the motors which are commonly used, or they have used a word. Okay, that is the important. So second and third only, that is option C is the correct option. Next, consider the buck converter with the controlled switch as MOSFET and uncontrolled switch as diode. The input to the buck converter is 60 volt. Input is 60 volt. The MOSFET is turned on for 20 microseconds and turned off for 10 microseconds periodically. Assuming ideal components, the output voltage of the buck converter is, they have asked the V0, that is output voltage of buck converter. What is the output voltage of buck converter? V0 average is equal to duty cycle D into supply voltage. What is duty cycle D? It is the on time divided by total time into supply voltage. So on time is 20 microsecond, 20 into 10 to the power minus 6 divided by total time is on time plus off time. So it is 20 plus 10, that is 30 microsecond into supply voltage is 60 volt. So if you simplify it, it is a 2 by 3, that is 120 divided by 3. So it is equal to 40 volt, right? 40 volt. So if you check the options, option C is the correct option, right? Yeah. Next, consider the following statements related to DC converters. The polarity of output voltage and input voltage of a single-ended primary inductance converter is opposite. Okay, opposite. Second one, the polarity of output voltage and input voltage of Cook converter is opposite. That is input voltage and output voltage polarity relation they have given. Okay, so if you check the polarity of output voltage and input voltage of single-ended primary inductance converter is opposite given. Second is polarity of output voltage and input voltage of Cook converter is opposite. So in the case of Cook converter, input voltage and output voltage polarity both are opposite. Also in a buck boost converter, in the buck boost converter also we are having the input voltage and output voltage polarity are opposite. So if you check here, the polarity of the output voltage and input voltage of buck boost converter is the same they have given. So this is not the correct statement. And the next one, the polarity of output voltage and input voltage of boost converter is the same. Yes, in the boost converter we are having the same polarity, right? Buck converter, boost converter, same polarity. Buck boost converter, opposite polarity. Cook converter, opposite polarity. So yes, second and the fourth are the correct options. So here you can check second and fourth, D. 2 and 4 are correct answer, right? D is the correct answer. Next, in DC power supplies, the switching frequency is much greater. DC power supply, why the switching frequency is greater? We know, because in order to reduce the size of the transformer, right? So here you can check the AC and frequency, right? The AC power frequency enabling the transformer to be ideal, right? So option D is the correct option. So these are the questions from power electronics. Next subject will be handled by the next faculty member, right? Thank you.
Let's look at the questions on computer organization. There are two questions based on computer organization. The first one is this. So, which one of the following controllers will check the status of each device and inform it to CPU? Actually, if you observe, all the four options are not appropriate. One is interrupt controller, which will deal with interrupts coming from the I/O device. It will not send the status to the CPU. DMA controller, it is going to be between the input-output devices and memory directly without the interference of CPU. So that's not appropriate one. Even disk controller, it is going to send the status of only about the disks to the CPU. So all the four options are wrong. Okay. So this is, if he has he given the answer as I/O device controller, then that would have been the correct answer. Yeah. Next one is called stack-oriented machine. When I discussed about the different types of CPUs, I told three types of CPUs. One is called accumulator-based CPU, second one is called register-oriented CPU, and third one is called stack-oriented CPU. So in this stack-oriented CPU, we use only zero address instructions. So that means what we do is, if you say it like this, the push A, it is going to push the value of A here and stack pointer comes here. After that, push the value of B here, after that stack pointer comes here. And then if I say add, I need not mention the operands here, it is going to take the top of the stack values. That is latest pushed values it will take, it is going to perform addition of these two numbers and it is going to store it as A plus B. So that's the reason in this stack oriented CPU, we do not require any general purpose registers, we do not require any accumulator because entire operation is within the stack memory. Now let us look at the options here. It contains an accumulator, wrong. Does not contain only a stack pointer which points to the stack pointer, stack top, wrong. Requires any operand address, no question of any operand address. Okay, and it does not contain any accumulator or general purpose register. This is the correct option. That's it. So which one is the true one among all the given options, and it's none other than the option is D. So these are the two questions based on computer organization. Thank you.
Right, welcome all. Let us see the questions given on communication in a electrical paper. Very good questions were given, numericals were pretty simple, and the theoretical questions were given, they are much more straightforward. The weightage is quite good this year. You got a very good model of questions. Let us see this. For an amplitude modulated double sideband full carrier, means he is talking about a standard AM. Double sideband full carrier, okay? A peak unmodulated carrier voltage VC is 10 times VP. So this VP is intentionally given, don't worry about that. That means he is talking about peak amplitude of the carrier. A load resistance of 10 ohms RL and a modulation coefficient mu equal to 1. What is the total power of the what is the total power of the modulated signal? So what is this formula? PT PC into 1 plus mu square by 2. This is the formula. Now, what is the power taken by the carrier? AC square by 2 into RL multiplied by 1 plus mu square by 2. Normally we take a normalized carrier power AC square by 2. When load resistance is there, substitute RL. So what will be this value? This is like 100 divided by 2 into value of RL is given as 10 into mu is given as 1. So 1 plus 1 by 2. It becomes 3 by 2. So this value will be, this goes here 10 times. So you will have 2 going here 5 times. 15 by 2, 7.5 watts. That's it, over. Pretty straightforward numerical. There is nothing much difficulty here. Okay? You can do within 1 minute time. Not a major problem. Let's see the next question. For a citizen band receiver using high side injection with an RF carrier of 27 megahertz and an IF center frequency of 455 kilohertz. What is the image frequency? So what is the formula for the image frequency? It is always equal to source frequency or tuned frequency plus 2 into FIF, intermediate frequency. Directly all the parameters are given to you. So what is this FS? 27 mega plus 2 into, what is the value of IF? 455 kilo. So this value will be 27 into 10 power 6 plus 450 into 2 is 900 and 5 into 2 will be 10. So this will be 910 kilo. So you can write your options in megahertz. So what you can write this? 27 plus 0.910 in megahertz. So your answer will be 27.91 megahertz. Try to do it in the simplest way possible. No calculators are allowed, so you have to adjust the terms accordingly. You will get it quickly. Next, let us see the next question. Which of the following statements are correct to improve the noise figure of a receiver? So he is dealing with noise figure of your receiver. So to improve the noise figure, what are the things that you need to do? Devices used for the amplifiers and mixers must produce low noise. Receivers can be operated at low temperature. High gain amplifiers are to be used to improve the noise figure. This is correct because when you use pre-amplifier stages, the overall noise figure will reduce. And the diode and FETs are preferred to improve the noise figure. This is also correct. So you can go with options 3 and 4. So you can go with the choice B. Okay? Pure theory question. Next. Any device or circuit whose output is not a linear variation with input can be used as. So any device or circuit whose output is not a linear variation with the input can be used as dash. Not a linear variation means what? Indirectly he is saying it is non-linear. That means your output, say the first order of non-linearity means second, n equal to 2, square operation. We can take this example. Y of t is like x square of t. So where will you use these type of cases in our communication things? If you see the options, RF amplifier is just an amplifying block. It will not change the frequency. It is just amplifying the amplitudes. Mixer, it will give sum and a difference of frequencies. But when you take a mixer, it is a combination of a difference of frequencies will be passed by the filter. That is operation of a mixer block. Okay, like F1 plus F2 and F1 minus F2 will come. F1 minus F2 will be passed by the band pass filter. That is the work of your mixer. Then IF amplifier, again the same logic. Whatever the frequency components you have, you are just doing an amplification there. Now see here, local oscillator, is it correct or not? What is the work of a local oscillator? You have to generate the carrier at the receiver end to get your demodulation done. So to generate such carriers at the receiver side, we make use of a local oscillator. Generally we represent it as FLO. Now these type of local oscillators, frequencies can be generated by using a nonlinear devices. So obviously your option can be option B. Okay, try to filter out the wrong options, then automatically you will get to this statement. Next, in the receiver parameter, fidelity is a measure of. So when we talk about receivers, we have selectivity, sensitivity and fidelity, three very important parameters. So what is the concept of fidelity? It should provide a constant gain or constant response in your usable frequency range. Suppose you are using a frequency range of your receiver between F1 and F2. So in this range, the gain has to be constant. If this is happening, then we say that your receiver size is having good fidelity. Now see your options. Ability of the receiver to accept a given band of frequency and reject all other frequencies. This is selectivity. Remove it. Minimum radio frequency signal level that can be detected. Sensitivity. Remove it. Then ability of a communication system to produce at the output of the receiver an exact replica of an original signal information. So wherever your frequency components are there, you need to get it exactly. Obviously your option will be C. Don't read D, waste of time. So once you find out the correct answer, go ahead with that. Next. Which of the following statements is correct regarding tuned radio frequency receiver? So what do you mean by tuned radio frequency receiver? They will have a response like this. For different frequencies, they will give different amplitudes. This is the funda of a tuned circuit. So we use these TRF receivers to get your frequency, Fs, selected by the receiver input. So the bandwidth is inconsistent and varies with center frequency when tuned over a wide range of input frequency. True, because your quality factor and resonant frequency are related with each other by this formula. So this is a major problem with the tuned frequency circuits. They don't have this constant bandwidth replica. That is the reason you are using superheterodyne receivers. You got your answer with option A. Don't even read the remaining options. Waste of time. Go for the next question. Next. Which of the following is a figure of merit used to indicate how much the signal to noise ratio deteriorates as a signal passes through a circuit or series of circuits? So that means, what is the meaning? He is talking about cascading of circuits here. You have different circuits connected in cascade. Series circuits in this current scenario is like cascading operation. So you have different cases of these circuits, like it can be an amplifier stage, it can be an RF stage, it can be an IF stage. Different stages are connected in cascade. So the overall performance at the output, how will you measure with respect to input? So the parameter that we use here is noise figure. That's all. F. That will be the right choice. Let's go for the next one. Which of the following is not a property of Gaussian random process? So be very careful. He is asking which is not a property. Okay. So when you deal with the Gaussian processes, what are the parameters of a Gaussian random process? You will have its mean, you will have its variance value, and you can also find out its mean square value. These are the parameters default present in a Gaussian random variable for a given Gaussian random process. Now see the options. A Gaussian process is completely described by its mean and autocorrelation. Absolutely correct. Because the density function of the Gaussian process or the Gaussian random variable defined in the Gaussian process itself will have these parameters. There is no need of exclusively defining these parameters. Next, if a Gaussian process is wide sense stationary, then it is stationary in the strict sense also. True. For a Gaussian random process, we don't differentiate between wide sense stationary and strict sense stationary, because Gaussian random process is default a second order random process. True. If a Gaussian process is given as an input to an LTI system, output process is also a Gaussian. Correct. So LTI system means what? Output is like some constant multiplied by input along with some linear increasing constant, plus B or minus B. So whenever you give a Gaussian input, output also will be a Gaussian output. That's a property of an LTI system when excited by a Gaussian process. Obviously your option should be D only, no doubt. If two processes which are jointly Gaussian are uncorrelated, they are also statistically independent. But he has given they are statistically dependent. Only word he missed is independent. So you should be very, very cautious while reading the statement. If you are saying that Gaussian random processes are uncorrelated, then the random variables defined in the Gaussian process are also independent. Both are same in Gaussian process. But here he is saying they are statistically dependent. So obviously your choice should be D. Next, a PCM system uses uniform quantizer followed by a 7-bit encoder, means n value given to you is 7. The bitrate of the system is equal to 50 megabits per second. What is the maximum message signal bandwidth? Message signal bandwidth means what? Message signal are low frequency signals, band limited signals. So they have the highest frequency component as FM, for which the system operates satisfactorily. So you know the bitrate of the system is n into fs. So the bitrate is given to you 50 mega equal to value of n is given. What is fs? Minimum sampling frequency is fq, which we write it as 2 into fm. Finish. So you have to find fm. So it will be 25 by 7 in mega. Who will cancel here 25 by 7. So 7 3 point something will come. No need to do the other calculations. You can go with option A. Okay. Don't waste your time in doing the calculations. Unnecessary calculations are not required. Next, assertion reasoning model. In FDM receiver, FDM means frequency division multiplexing. So you take different modulated signals centered at different carrier frequencies, multiplex them and transmit over a channel at single point of time. That is a funda required. In FDM transmitter, if the signals which are to be multiplexed will each modulate a separate carrier, means he is saying different carrier frequencies like FC1, FC2 and so on, then the type of modulation can be AM, SSB, PM or FM. Actually it's printed wrongly here. It is FM or PM. Fine, this is correct because you basically use FDM for analog modulation techniques. All these listed values are analog modulation only. Statement 2, in FDM transmitter, the modulator outputs will contain the sidebands of corresponding signals. Correct. Both statements are individually true, but there is no relation between A and, supporting answer that is given in the statement 2 is not that in statement 1. So obviously you can go with option B. Next. Consider the following statement regarding differential pulse code modulator, DPCM system. So DPCM is basically extension of PCM where you use this to increase the signal to quantization noise ratio without touching the value of n. That is a concept. Now see your options, we can easily filter them. The DPCM system employs a predictor. Predictor means a difference between the present and next incoming sample. Correct only, no doubt. Then it needs far fewer bits per each error sample than what would have been needed for the original samples themselves. Correct. It will have larger dynamic range than the original message signal. Dynamic range actually decreases. When you go for DPCM, what we are actually doing, we are taking the difference between the present and the next incoming sample, and these sample inputs are given as an input to quantizer. So what is happening? The effective dynamic range means, which we are writing as the difference of maximum voltage and minimum voltage decreases. Because this decreases, your quantization noise power decreases. Because the quantization noise power decreases, overall signal to quantization noise ratio increases. So he is saying here very clearly it will have larger dynamic range. Basically it is going to have lesser dynamic range. So you remove the option that is 3. So all these are having 3. Remove them. So only possible choice is option C. That's it. That will be the right choice. So these are the questions given in communication area. Pretty straightforward and easier question. Now my colleague will take the remaining part of the questions.
Yes, everybody, you are eagerly waiting for electric circuits. This time it is fantastic, easiest of all. Okay, only 8 questions came and hardly it will take 5 minutes. Okay, of course there is slight ambiguity in some questions. We will talk because negative sign is not given in one of the voltage, but you can take the best and whatever is the best available. In ESE that is necessary, you know. Yes, the Thevenin's equivalent. Yes, the Thevenin's voltage and Thevenin's resistance. First of all, Thevenin's resistance, it is category 1 problem with only independent source. You short it. So what is RTH easily? Yeah, what is RTH? RTH is clearly 5 in parallel to 20. It is 4 ohm. Yes or no? Then what is Thevenin's voltage? Voltage division rule. Easy, 1 minute voltage division rule. Total voltage into same by sum. Same is 20 by sum is 25. It is obviously 40 volt. 40 volt 4 ohm. Option A. Okay. Let us be very simple. See, IS in such subjects save some time. Then here C equivalent. Now see, he gave a lot of things, but here yes, series parallel combination of capacitors formula is ulta to resistor, okay, opposite to resistor. Now these 3 are series, but what is 1 by C total? Like 1 by C1 is 1 by 1 micro plus 1 by 5 micro plus 1 by 2. Take LCM 10, okay, you will get 17 here. So C1 will be 10 by 17. Now 10 by 17 is in parallel to 12, is in parallel to 12. That is something like C2 until here. Then again these 2 are in series, okay. So these 2 are in series. If you take this as C3, 1 by C3 is equal to like 1 by 0.4 plus 1 by 0.8 plus this is ulta, okay. That is 17 by, okay, you will get something 214. If you do that, yes, this will be something like 0.26, so 0.26 microfarad. Then finally, these 2 are in series, then parallel. So altogether you will get the nearest answer as 3.18. So this is a calculation bit. Of course, you may say, sir, with calculator or without calculator, how we can do? So you have to be very clever. Yes, sometimes I suggest, yes, such answers you have to be expecting the nearest one or you leave it. But you struggle in calculating series parallel, it will take time. Okay, better careful, but answer is 3.18 microfarad. Okay, then consider the following statement with respect to Kirchhoff's laws for a circuit comprising of resistors and independent sources. The number of, yes, which is, see, the question is which of the following above statements are not correct or not correct. Now here also there is some ambiguity because you see, consider the following statements on Kirchhoff's laws for a circuit comprising of only resistors and independent sources. The number of independent element volt ampere equations is equal to number of resistances, meaningless. Suppose in a loop, in a loop or a mesh, we can combine elements now, so this cannot be. And the number of independent KVL equations is equal to one more. Now this is the ambiguity I was talking. Then the number of independent KVL equations is independent loops because mesh equations are nothing but meshes are independent loops. Meshes are independent loops. Always remember. Meshes are independent loops. So this is the most correct one. But he is asking which is not correct. Now one is clearly not correct. There is an ambiguity with this. So yes, the best option is this. So which is not correct? One is clearly not correct. And there is no other option we can tick. Because 3 is perfectly correct because the number of KVL equations is equal to number of independent loops, which is mesh equation. Then here, yes, what is the voltage V in the circuit? Okay, now see here, there are 2 current sources which are in opposite direction. First of all, 2.5 ampere up, 2.5 ampere down, they cancel each other. Then there is only 5 ampere going this way, 5 ampere is going this way. But one common sense, because these 2 cancel, so forget about it. Now 5 amperes is going, but these 2 are parallel. 5 parallel is how much? 2.5. So now this voltage will be minus of 5 amperes into 2.5. So minus 12.5 volt, minus 12.5 volt. But he forgot to give minus, answer is this. Because in a passive element, the direction in which current entry is taken as positive, but he gave ulta. Okay, that is the easiest way. Then when angular frequency of DC source is 0, yes, 0 frequency, ideal DC 0 frequency, capacitor acts as and inductor acts as. Of course, you should mention it is in steady state. It is understood. In steady state, yes. We know in inductor, V is L di by dt. But when there is no change, angular frequency 0 means no change, di by dt is 0, voltage across inductor is 0. So inductor acts like short circuit. And in capacitor, I is C dV by dt, yes or no? And again, 0 frequency means no rate of change. So I is 0, IC is 0, so it acts like open circuit. So inductor acts like short circuit, yes. First capacitor acts as open, inductor acts like short. So option B. Because he asked first capacitor acts as open respectively, okay, inductor acts like short in steady state. Then the time constant, now the definition, this is everywhere the first point I teach in transient chapter, everywhere it is a definition. time constant, is the time taken by the response to reach, yes, 63.2% to its final value. Okay, in a step response case. In a source free, it is also defined as the time taken to reach 36.2% of its, 36.7% of its initial value while decaying. But this is 63% to its final value. So steady state is final value, na? So don't confuse with this and this. Off process 36.8% of its initial value. On process 63.2% of its final value, steady state. So this is the correct option. Actually, both you may confuse. During off process, it is 36.7% of its initial value or 63.2% to its final value. So option is B. That is obviously B. Then transient disturbance is produced in a circuit when? Yes, when transients happen, whenever there is a sudden change. Whenever there is a sudden change. Now look at the option. Yes, currents in circuits are associated with resistor. No, resistor will never create transient because resistor has the ability to convert and dissipate energy in the form of heat. So not a problem. So circuit is suddenly connected or disconnected from supply. Of course, this circuit must consist of energy storage element, inertia elements. Okay, inertia. Source is overdamped, source is underdamped, nothing can be done. So yes, this is basically circuit. So option B. Circuit is suddenly connected or disconnected. Step response or source free. But understood that circuit has energy storage element. Purely resistive never create transient. Okay, na? So option is B. Then at off resonance frequencies in parallel resonance, the phase angle is greater than. Now listen, at resonance frequency, phase angle is 0. And off resonance means any frequency other than it should be greater than 0. Greater than 0. Here something to confuse. It is a concept question, like it is only based on English, like the off frequency other than resonance frequency, the phase angle is definitely greater than 0. Either lagging or leading, it should be greater than 0. So answer is greater than 0. Option is A. Okay. So circuit, it is so simple that in hardly 5 minutes you can attempt 8 questions. Okay. I will now request my next faculty to go on with the next subject, computer fundamentals, etc. So I welcome him. All the best for your result.
So coming to the computer fundamental questions as part of this ESE 2022 examination. So look at the question statement. Which one of the following layers in PCI Express protocol architecture is used for compatibility with the PCI initialization and enumeration of the devices connected to the PCI Express? Option A, PCI Express physical layer. Option B, software layer. Option C, data link layer, and option D, hardware layer. See, if you recall this, if you consider this PCI Express protocol architecture, it is similar to ISO-OSI reference model, which is part of computer networks, right? So in that ISO-OSI reference model, we are having 7 layers. In the same way, in this PCI Express protocol architecture, we are having 7 layers. So among those 7 layers, see, like application, presentation, session, transport, network, data link, and physical, these are the 7 layers we are having. But among them, if you verify, if you recall those layers, one is application, presentation, session, transport, network, data link, and physical. Among these layers, if you compare these layers with the options, we don't have any software layer and we don't have any hardware layer. So we are having PCI Express physical layer and data link layer. So among these two, which can be the answer here? For that, if you verify remaining question, it is mentioning that initialization and enumeration of the devices. This is done by your physical layer. Initialization, it is done by the physical layer but not with the data link layer. So hence option A is the answer for this question. Okay, right. Look at the next question. So coming to this question, which one of the following tools is used to protect critical sections and prevent race conditions? See here, critical section. What is the meaning of this critical section mean? It contains the shared resources. So shared resources are there. So with respect to our inter-process synchronization of operating system, a process is divided into 2 parts. One is critical section part, another one is remainder section part. The critical section part contains shared resources, whereas remainder section contains non-shared resources. So the shared resources needs to be protected here, and we need to prevent the race conditions. What is this race condition? So race condition definition is when when multiple processes are trying to access the same data at a time, then the outcome of that execution depends on the order in which the execution of taken place. This is what your race condition definition. So we need to prevent the race conditions and we need to protect this critical section. See, what are the various race conditions we are having? The first race condition is there is loss of data. There is a possibility for loss of data if there is no synchronization between processes and inconsistent results. This is also another race condition if we don't have inconsistent results, if we don't have proper synchronization between the processes. And there is one more race condition which we can call it as deadlocks. So these are the race conditions which we are facing if there is no synchronization among the processes, and we need to protect the critical sections. So means that if you consider among the options, these two are contradictory options here, option A and option B, but the most precise answer can be decided like this. So if you consider this semaphore can be a binary semaphore, it might be a counting semaphore. It can be a binary semaphore and it can be a counting semaphore. Binary semaphore is also called as mutex, which stands for mutual exclusive. So mutual exclusive in the sense the critical section is operated by the processes in a accessed by the processes in a mutual exclusive manner. So hence mutex is the option we are having here. So this is the appropriate answer here, but this cannot be an appropriate answer. I can say that this is the precise answer for this question. People can choose this one also, but mind that the semaphores are classified into 2 types. One is binary semaphore and counting semaphore. This counting semaphore violates the mutual exclusion, whereas binary semaphore can ensure the mutual exclusion. Hence, the precise answer for this question is mutex lock, option A. Okay, right. So look at the next question. So to arise a deadlock situation, which of the following conditions hold simultaneously in the system? This is the question directly we have from our materials, and we have gone through this concept of the deadlock in our ESE mains examination classes also. Try to recall, to arise the deadlock situation, which of the following conditions hold simultaneously in a system? So if you want to, so what are the necessary conditions? So necessary conditions for occurrence of deadlock, if we consider necessary conditions for occurrence of deadlock, deadlock. So what are the necessary conditions for occurrence of deadlock we have? The first one is mutual exclusion. The first one is mutual exclusion. And the next one is hold and wait. And the next one is no preemption. No preemption. And the next one is circular wait. So these are the necessary conditions for occurrence of deadlock. So among these options, among these 4 necessary conditions, if you verify the options, yes, mutual exclusion is there, fine. Hold and wait is also there, fine. But coming to the third one, it is saying that no preemption, but here it is preemption. So that this cannot be the correct answer. So what is the answer here? Both 1 and 2 are necessary conditions for occurrence of deadlock. So 1 and 2 is the answer that is matching with option B. Option B is the answer for this question. Right. So let us look into the next question. Right. So look at this question. Which one of the following issues are addressed by redundant array of independent disks? See, if you consider this redundant array of independent disks, this is the acronym for RAID. This is the acronym for RAID. So this redundancy, redundant, it is clearly saying that what is the meaning of redundancy? Multiple copies of data. So the main intention of this particular RAID is it maintains multiple copies of data. It maintains multiple copies of data. Multiple copies of data. So whenever we are having multiple copies of data, if any disk is failed, then from other disk we can get it. Correct na? So it means that reliability is ensuring here. That is what the main purpose of this RAID. The main purpose of RAID is it is ensuring reliability by maintaining multiple copies of the data into multiple disks. So that is why performance and reliability is the correct answer for this question. As it is clearly reliability. The main intention of this RAID is reliability. Okay? Right. Look at the next question. Virtual memory implements the translation of programs address space to option A, virtual addresses, option B, physical addresses, option C, mapping addresses, and option D, page addresses. See, virtual memory, basically this is used for what? This is used for converting the logical address space into physical address space. So logical address space is called your program's address space. So logical address space is your program's address space. Your physical addresses, it means it is your physical address space, right? So this is your program's address space, and these physical addresses are PAS, which is physical address space, is also called as your main memory. So this virtual memory is implemented for the conversion of logical address into physical address. So hence option B is the answer for this question. Okay, right. Look at the next question. Which one of the following provides an interface to which a client can send request to perform an action? In response, the server executes the action and sends back result to the client. Option A, file server system. Option B, open source system. Option C, computer server system. And option D, peer-to-peer system. Which is the answer? See, understand the point here. Here we are performing some action. So some action in the sense it might be related to some computation. So generally in computers, we used to do computations. That is what the action here. Some processing can be there, right? But if you consider first file server system, see basically the file server system maintains the files. Basically the file server system maintains the files. Whenever a file required, whenever a device required some file, or else whenever a system required some file, that system can retrieve that file from this file server system. So just it is transferring the files. Whichever system is requesting some file, that file it is being transferring to that particular system. It is not doing any action, so that we can ignore this option A here, right? But among the remaining options, if you verify, look at option D, it is mentioned that peer-to-peer, but basically you are having client. Here it is saying that there is a client and there is a server. So it means that it is speaking about client-server systems, but not peer-to-peer systems. Client-server systems in the sense one system can have entire control on the network, which is having server, that is called server. But peer-to-peer, all are having equal, right? So means that obviously this could be out of race, right? Then among the remaining options, if you verify, option C is the answer for this question, okay? Right. So let us look into next question. Right, so look at this question. Which of the following statements are correct regarding multiprocessing architecture? 1. It can cause a system to change its memory access model from uniform memory access to non-uniform memory access. 2. There are two types of systems such as asymmetric multiprocessing and symmetric multiprocessing. 3. It adds CPUs to decrease the computing power. Select the correct answer using the code given below. Option A 1 and 3 only, option B 1 and 2 only, option C 2 and 3 only, option D 1, 2 and 3. See, based on one statement, you can answer this particular question. Look at, what is this? It adds the CPU to decrease the computing power. Actually, multiprocessor systems are meant for what? Speed up, right? Multiprocessing architecture is meant for speed up, for the speeding of computation. But here it is mentioned that adds CPUs to decrease in the sense, which is the wrong statement here. This is the wrong statement. So actually these multiprocessor systems, if you add some CPU, the computation power gets increased. So as it is given decreases, this is false. This statement is false. So among the options, if you verify, with 3, what are the options you are having? You need to find out the correct answer, but this is incorrect answer. So here option A 3 is having, option C is having 3, and option D also having 3. But this 3, wherever you are having, they are all wrong answers because third statement is false. So what else remaining? Option B. So that option B is the answer for this question. Right. So that's it. This is the part of computer fundamentals. Thank you. I would like to request my next colleague and my friend Vivek sir to discuss about EMTL concepts. Thank you.
Welcome friends, good day. I am Vivek Narsampalli. I am going to deal with the questions which are related to the electromagnetic fields. Here is a question. Which one of the following statement is not correct regarding the potential due to the point charge? If you remember, the potential due to the point charge is given by V is equal to Q by 4 pi epsilon R. That is the formula. That is the potential due to the point charge. Now read out the statements here. It is directly proportional to the magnitude of the charge. Yes, this is the first statement, correct. Second statement, it is inversely proportional to the distance from the charge. Yes, it is inversely proportional to the distance. Third statement is, it is inversely proportional to the relative permittivity of the medium in which the charge is placed. Yes, it is inversely proportional to the epsilon. So obviously it is directly, what it is mentioned is, it is directly proportional to the electric field intensity. No, you can check out from that option. So this is a wrong statement. So obviously this is the answer. Fine. So now let us take one more question. Very straightforward this one. The relation between the electric flux density D and the field intensity E, actually it is E, with absolute and relative permittivity is expressed as, we know that D is equal to epsilon into E, where epsilon is equal to epsilon naught epsilon R. Is asking expression for the E. Fine. So what is the expression for the E? E is equal to D by E, which is epsilon naught epsilon R. Very simple and straightforward. So the option B is the answer. Okay. Now let us take one more question, which is on the energy stored in the inductor. If the L is a self-inductance and I is a current, lambda is the flux linkage of the magnetic field, then the energy stored in the magnetic field. So what is the energy stored in the magnetic field when you talk in terms of the inductor? There is a popular formula, H is equal to half Li square, or you can also write in terms of flux 1 by 2 into I into phi. So where phi is equal to, where L is equal, is asking in terms of, here the phi is lambda, 1 by 2 into I into lambda. But how this I can be written? L is equal to I into, sorry, by definition L is equal to phi by I. So here it is lambda by I. You can substitute there. So the work done is equal, energy is equal to 1 by 2 into. So in the place of lambda you can substitute. In the place of I you can substitute lambda by L into lambda. So here it is lambda by lambda square by 2L. Lambda square by 2L. Lambda square by 0.5 into lambda square by L. Option A is the answer. Yes. So here it is I is equal to, you can write this one as I is equal to lambda by L. You can just substitute there. This is the play of formulas. Fine. So these are the answers for the electromagnetic theoretic question related questions. Now I'll going to hand over the sessions to our faculty friend, eminent faculty for the material science.
Right. I'm Madhushekar, faculty of ACE Engineering Academy. Here I'm going to deal with material science questions for ESE 2022. Here is the statement question. The statement one is given. Aluminum oxidizes quickly in normal atmospheric conditions and acquire thin film of oxide, that is aluminum oxide. Okay. So aluminum easily reacts with oxygen and forms oxide, and it acts as a protective layer to avoid corrosion. The high melting point of aluminum oxide coating and the rapid rapidity with which freely exposed aluminum surfaces becomes oxidized make soldering difficult through the conventional means. Yes, it is correct. Because of this aluminum oxide formation on the aluminum plate, the soldering is difficult. Soldering is difficult because of this aluminum oxide layer. So here statement 1 is correct and statement 2 is also correct. Okay, statement 2 is also correct, but it is a reverse statement actually. This is the statement. For this statement, reason is this one. Okay, the question is here why the aluminum material is not solderable easily. The reason is because of formation of aluminum oxide on the surface. Right, sorry for the disturbance. Here the statement 1 and statement 2 both are correct here, but statement 2 is not correct explanation for statement 1. The reverse it is given. Why the aluminum sheet or aluminum metal is not solderable easily, why it is difficult, that is because of aluminum oxide layer is formed on the surface. It's a passive layer because of high melting point temperature. So I'll give you for this question, I'll give you answer for this question is B, because statement 1 and 2 are correct, but statement 2 is not correct explanation for statement 1. Now, choke coils are made of iron core because of its high inductance, that is nothing but high magnetic flux density. Because if I consider a choke coil, this is a iron core, it is a rod iron core, surrounded by that a copper coil is there. This copper coil is having, okay, very low resistivity. Because of low resistivity, high magnetic inductance is generated in the iron core, so that large value of flux densities can be produced in the iron core here. So this is the option B is the correct one for this question. Now, which of the following defect might be thought of as being formed by cation leaving from its normal position to moving an interstitial position? So this is cation, anion, like that. If I consider an ionic material, okay, if I consider an ionic material, in case a cation, that is a positive charge ion, if it is moving from its original position to the interstitial position, then the type of defect is known as a Frankel defect. Schottky defect means missing of pair of atoms. So Frankel defect is the most appropriate answer for this question. Right. The next question, which of the following classifications are correct with reference to the various types of imperfections in semiconductor? So all type of point defects are present in the semiconductor, that is a substitutional defect, that is a p-type and n-type semiconductors are formed by the substitutional defect and by creating vacancies also, and also interstitial defect. This is interstitial defect. So the most appropriate answer for this question is D, 1, 2, 3. Now, which one of the following statement is not correct regarding superconductivity? The statement 1, not correct here. See, listen carefully, here it is not correct. Statement 1, otherwise first option, superconducting compounds and alloys do not necessarily have compounds which are themselves superconducting. Right, correct. For example, I'll consider an example of high temperature superconductor like yttrium, barium, copper oxide. It's a high temperature superconductor, right? It's a compound. Now if I consider copper oxide CO, copper is not a superconductor, but copper oxide is becoming superconductor, so this statement is correct. Now another question, metals which are very good conductors at room temperature do not exhibit superconducting properties. Yes, correct. For example, copper, silver, gold, these are very good conductors at room temperature, but they are not becoming superconductor because of weak Cooper pair formations, right? So this statement is also correct. And the metals and compounds, third option, metals and compounds which are superconductors, conductings are at rather bad conductors at ordinary temperature. Metals and compounds which are superconducting at a low temperature, rather bad conductors at ordinary temperature. Yes, that is also, we can't say but exactly. Now another important thing here, monovalent metals, ferromagnetic and antiferromagnetic materials are superconductor. This is not at all correct, because like iron, cobalt, nickel, gadolinium, these materials are ferromagnetic materials. These are not forming a strong Cooper pairs, so they're not good conductors. They're not becoming superconductors. So this statement is not correct. So in the question it is given not correct. So the answer for this question is D. It's a very simple one. Next, it's a very formula based one, Bragg's law. So Bragg's law is nothing but n lambda is equal to 2d sin theta, right? N lambda is equal to 2d sin theta. So straightforward question. So n lambda is equal to 2d sin theta. Option A is the correct one for this question, right? Now the next one, what is the approximate diameter of copper wire of length 100 meter if it is to be used as a winding material in the transformer such that the resistance of the whole winding is 2 ohm. Now see here in the question, length is given 100 meters, right? And resistance is given R is equal to 2 ohm, and resistivity is given 1.7 into 10 power minus 8. So very basic formula, rho is equal to RA by L, right? Rho is equal to RA by L, right? Now substitute in this equation 2 into pi r square divided by 100, okay? Calculate from this radius and from that diameter, that is 2r. They are asking 2r, right? From this calculate radius and from that diameter 2r. So I think the appropriate answer for this question is 1.04 mm, right? Directly I am giving, but as a very simple formula, by using this formula you will get the answer. So I think this is the one. Now the next one, the temperature above which the ferromagnetic material lost its magnetic properties called as a Curie temperature. It's a basic standard, basic fundamental question. So below Curie temperature, the material acts as a good ferromagnetic material, but above that it is a non-magnetic or a paramagnetic material, right? Next, there are some metals and chemical compounds whose resistivity becomes 0 when their temperature is brought nearer to 0 Kelvin. Such materials are very easy definition of the superconductor, right? It's a definition of superconductor. Superconductivity is nothing but it's zero resistivity or infinite conductivity below a particular critical transition temperature that is at nearer to 100 Kelvin. So the answer for this question is B. Now another question, a blue lamp emits light of mean wavelength. In the question it is given lambda. The lamp rated at 150 watts, this is the power, this is given in the question 150 watts, and 8% of the energy only appears as emitter light. You have to remember this, only 8% of the energy which appeared as a light. From that, photons are going to be released. How many photons are emitted from the light? This is my question. So generally energy E is equal to number of photons into Planck's constant into velocity of the light divided by the wavelength. This is the basic formula. Here energy is what? Generally in the question it is 150 watts is given, that is the total energy. But out of the total energy, only 8% of the energy is used as a light, is emitted as a light. So I can take 0.8 into 150, that is equal to number of photons into Planck's constant, that is 6.625 into 10 power minus 34 into the velocity of the light is 3 into 10 power 8 divided by lambda, that is 4500 into 10 power minus 10. Right. By solving this, you will get the value of n, that is approximately 27.15 into 10 power 18 is the number of photons per second which is released from the light. Right. The next question, it's also a very simple question. What is the energy lost per hour? So in the question it is given energy lost per hour in a specimen of iron subjected to magnetization. So in the question it is given at a frequency of 50 cycles per second. Okay. Specimen weight is, mass is given 50 kg, mass is given 50 kg, and the hysteresis loop equivalent area is given, that is nothing but hysteresis loss. Okay, hysteresis loss is given in terms of joules per meter cube. Okay, na? And the density is given in the question, that is 7500 kg per meter cube. So it is given joules per meter cube. Now I want to calculate joules per cycle. Hysteresis loss, that is joules per cycle, that how can I calculate? 250 into mass 50 divided by 7500 density, that is nothing but joules per cycle. Now how many cycles are there? 50 cycles are there. Hysteresis losses, that is 250 into 50 mass into 50 cycles by 7500, that is joules per second. But in the question it is asking joules per hour. By multiplying this with 3600, otherwise 60 into 60, you will get the answer, that is 3 into 10 power 5 joules. It's a very simple basic fundamental question. Right. So answer for this question is 3 into 10 power 5. Right. The next question, a good insulating material should possess which of the following characteristics? See, good insulating material should be having very high dielectric strength and low permittivity, high temperature strength, high mechanical strength, chemical stability, like that. So high dielectric strength is given in the question and low permittivity is given in the question. High temperature strength should be, thermal strength should be very high. It is not low. So 1 and 2 are the correct answers for this question. Why it is should be having very high temperature strength? Because during working of this insulating material, sometimes heat is going to be generated. In case if heat is more, maybe the material is going to melt or burn out. So it should be having high thermal strength. So answer for this question is A. Another question here, most substances are not magnets because, see, in the universe only some of the materials are magnets because they are having the free valence electrons, otherwise due to the electron motion or spin of electrons, right? So we'll see that question, why materials are not magnets? They do not have sufficient energy to produce magnetic behavior, is not correct. At atomic level, magnetization is generated because of electron motion, right? And their electrons do not move truly, it's not correct. Electrons usually pair off and their spins opposite to each other, okay, they are going to be cancelled out. Now for example, if I consider a d orbital, otherwise a p orbital, if I consider a p orbital, initially the electrons are located like this and they are located like this reverse. So the electrons are completely filled in the p orbital, so there is no net magnetic moment here. So this is the correct statement. The electrons usually paired up with their spin opposites to each other so that their fields cancel each other. So for this question, this is the answer. C is the correct one. Right. Next, whenever a particle has an angular momentum, it will contribute to a permanent dipole moment. Which one of the following does not contribute to the angular momentum of the atom. See, angular momentum of the atom is generated basically spin of electron, orbital motion of the electron, and nuclear spin of angular momentum. There are three types of angular momentums. See, remember, orbital angular momentum of electron, electron spin or spin of electron, and nuclear spin of electron, but proton spin of angular momentum is not there. So which one of the following does not contribute to the angular momentum of the atom? So that is proton spin of angular momentum. So B is the correct one for this question. Nuclear spin of angular momentum is there, but it's a small quantity, small magnitude compared to the electron and spin and orbital motion. But anyhow, it is one type, so that's why I'm not considering D as the answer. I'm considering B as the answer. So these are the questions related to material science. And next, my colleague Prasad sir will continue.
Hi, I am Dr. EVS Prasad. Here I am going to solve mathematics questions given in electrical paper. Right. Let's see the first question. A workshop has several machines. During a typical month, 2 machines will break down. The probability of more than 2 machines will break down in a month is what? So this problem is related to Poisson distribution. Here given that during a typical month, 2 machines will break down. So clearly lambda value 2 only. What is the required probability? Probability of more than 2 machines will break down. That is probability of x greater than 2 is required. So probability of x greater than 2 means what? We know that for this type of problems related to Poisson distribution, we take the complementary property. We use the complementary property. So 1 minus probability of x less than or equal to 2 only. So 1 minus probability of x less than 2 means what? 1 minus probability of x equal to 0 plus probability of x equal to 1 plus probability of x equal to 2 only. Right. So this is going to be, so 1 minus, this is e power minus lambda, lambda power 0 by 0 factorial. So lambda is what here? 2 anyway, right? So here e power minus lambda into lambda power 1 by 1 factorial plus e power minus lambda into lambda square by 2 factorial. So this is going to be 1 minus, so this is e power minus 2 plus this is 2 times e power minus 2 and lambda square means 2 square by 2 factorial means 4 by 2, that is 2 only, so plus 2 e power minus 2. So finally this is going to be 1 minus 5 into e power minus 2 only, e raised to minus 2. So which option? Option C is going to be correct answer. Let's see the next question. So villages A, B, C and D are connected by overhead telephone lines joining AB, AC, BC, BD and CD. As a result of severe gales, there is a probability P that is the same for each link. So that any particular link is broken, then the probability that a call can be made from A to B is what? Right, simple, we can solve like this. So A, let be B, C, D. So given that AB, AC and BC and BD and CD. So what required probability is what? then the probability that a call can be made from A to B is what? Right. So first we find the probability of call cannot be made from A to B. Then we take the complementary, right? So probability of right, call cannot be, right, from A to B. Okay, look at how to calculate this one. So we cannot make the call from A to B if A to B, A to C both are failed. That is AB, AC both are failed. Or next one is AB failed, the link AB is broken, right? And AC is okay, AC is okay. And next one is CB failed and CD failed. This is one way, another, right? Similarly, one more possibility also we have. So R, that is AB failed, AC failed, AC okay, CB failed, CD okay, but DB failed. So these are the possibilities. So once you observe, right, we can observe that in the given data, what is the probability of a particular link is broken? P is the probability, given probability. So therefore, it is going to be, by simplifying, this is going to be P into P, first one, plus next one is AB failed means what? Probability of link is broken is given that P, so P only, this one. But AC is success means what? That is 1 minus P, right? Next again P, next one is 1 minus, again P only. Again P only. So once observe, similarly next one, next term also something, right? Once observe these terms, here you get P square, P cube, right? Next also P cube, something P power 4 we get. But first term is what? P square. So I am writing P square plus something, right? Some terms. So, but what we want the probability from, probabilities that call can be made from A to B, right? So therefore, required probability is equivalent to 1 minus, right? Complementary property we are using. So 1 minus P square plus something, right? Something, these two terms. So once observe the options, right? If you observe the options, clearly only first option is the possible answer, right? So option A is the correct answer. Am I clear? See once the explanation, right? Let's see the next question. What is the regression line of y on x for the following 6 pair of observations? Right. So x values, one y values are given. Which of the following is the regression line of y on x? Right. So we know that regression lines are passing through the x bar y bar point. So the correct answer means regression line of y on x or x on y should satisfy the point x bar y bar. So first we calculate the x bar. X bar means what? You know that mean of x. So x bar is what? 1 plus 3 plus 4. 4 plus 4, 8, 8 plus 5, 13, 13 plus 7, 20, 28. 28 by number of observation is what? Number of 0.6. So this is going to be 4 point something 66. Next y bar equal to, y bar means what? Again mean of y series. That is 2 plus 8, 10, 19, 29, 29 plus 14, 42, 42 plus 43 plus 19. That is 62. So 62 by 6 only. So this is going to be 10 point something 33. So verify the options once which satisfies. Look at once here. Option A, if you consider see the option y equal 1.18 into x. X means what? 4.6. 1.1 into 4.6 means 4 point something minus 0.49. But right hand side 10.33. So option A will not be. Option B will not be. Next, once observe option C also. Y is 10.33 equal 2.18 into 4.66. So approximately we get 10 point plus 49, 10.49. But right, left hand side is 10.33 only. So option D satisfying. That is what we can observe, you can verify 10.33 is equivalent to 2.18 into this x value 4.66 plus that 0.16. So these exactly both are equal. So option D is going to be correct answer. Right. Next one is, let's see the next question. A bag contains 50 balls of which 10 are red and the remaining black. So if 2 balls are drawn successively from the bag at random, what is the probability of selecting one red ball and one black ball? Very simple question. So out of 50, 10 are red. So 10C1 into 40C1, because 40 are black balls and we are selecting 2 balls, so by 50C2. So you can simplify this one. 10C1 means 10 only. Similarly 40C1 means 40 only. And this one 50C2 means what? That is 50 factorial by 48 factorial into 2 factorial. Simplify this expression, it is going to be 16 by 49 only. Let's see the next question. A random variable y has a known probability distribution given by y values 2, 4, 6, 8, etc. and corresponding probability, then the expected value of y is. We know that expected value of y equal to, what is the formula? Expected value of y means that is sigma yi into corresponding probability pi. Am I right? So it is going to be 2 into 0.17, so 0.34 plus this is 4 into 0.23, that is 0.92, and this is 1.2, and this is 2.4, and this is 10 into 0.1 means 1 only. So you can simplify this one. This is going to be 5.86 only, right? Equivalent to. So option C is going to be correct answer. Let us see the next question. The Fourier series for f of x equal to sin 2x defined over the range minus pi less than or equal x less than pi is what? Right. So very simple. F of x equal to, given that sin 2x only. So we know that by trigonometric identity sin 2x can be written as 1 minus cos 2x by 2 only. So this is going to be 1 by 2 minus cos of 2x by 2 only. So option A is going to be correct answer. So I am handovering this session to my colleague Aditya Srinivas sir. He will continue the session. Sir, welcome sir.
Let's look at the other questions. A and B are real, non-zero 3 cross 3 matrices and satisfy the equation. So some equation is given. AB whole transpose plus B inverse A equal to 0. And B is orthogonal. So what do you mean by orthogonal? The condition for the orthogonal is B transpose is B inverse. Now you can use that. So AB whole transpose is B transpose A transpose plus, I'll send this the other side. So this is like minus B inverse into A. In the place of B transpose, I can put B inverse. So this is like B inverse into A transpose equal to minus B inverse into A. Now you see this is B inverse here, B inverse here. If you compare, it's very clear that A transpose is minus A. Any matrix satisfying this condition, A transpose equal to minus A, it's an example of skew symmetric matrix, which is nothing but this anti-symmetric matrix. The answer for this question is option B. What are the values of alpha and beta that make this, okay, so some differential equation is given that makes this an exact differential equation. So now you can compare this with mdx plus ndy. So what's the condition for this mdx plus ndy to be called as exact differential equation? Dou m by dou y must be equal to dou n by dou x. Now look at this is m, this is n. I need to find dou m by dou y, which is minus alpha by y square equal to dou n by dou x, the partial derivative of this with respect to x, which is y beta. So what I have to compare now, this is like minus alpha y power minus 2 equal to y power beta. So now clearly beta is minus 2, alpha is minus 1, right? Alpha minus 1, beta minus 2, it's option A. Now they gave a function f of x comma y, it's a function of two variables, okay? So b is not equal to 0, has 2, 1 or 0 stationary points according to whether mod b is dash, and various options are given. So he talks about stationary points. The procedure is find dou f by dou x, dou f by dou y, equate them to 0. So what is this dou f by dou x? So I'll simply write this as fx, which is 3x square minus 12y and 48, right? So what is fy? Fy is minus 12x and then plus 2by. You need to equate both of them to 0 to get the stationary points. When I equate this to 0, I get minus 12x equal to minus 2by. So this cancels this cancels by 6. 6x equal to by. So what's y? Y is 6x by b. Now let's substitute y equal to 6x by b into this fx equal to 0 and then solve for the values of x. So let's solve this. So when I substitute this, so what do I get? I get 3x square minus 12 into 6x by b and then plus 48 equal to what? 0. You need to solve this quadratic equation, and then looking at the roots, you need to comment about the stationary points. So when I find this, so let's multiply b as well here, and I want to take 3 out, so it's b x square. So I have taken 3 out, so it's minus 24x. I have taken 3 out, so it's plus 16 equal to 0. Now you have to solve for the roots of x, that is x equal to minus b plus or minus, that is 24 plus or minus root of 24 into 24 minus 4ab, that is 64b. 64b, that is 2 into b. So now, looking at this, we can comment about the stationary points. Now look at this discriminant, that is this part. If this part is greater than 0, what happens? If this part is greater than 0, you will get real and distinct roots. That means you get two different values for x. Two different values of x gives you values for y. That means you get two stationary points. So for that, what we need to do is we need to equate this. We need to do something like this. 24 into 24 minus 64b must be greater than 0. So now let's simplify this. So 24 into 24 by 64, right, greater than what? B. Now you can go for the cancellation. This is 16 here, 6 here, 4 here, and then 6 here, and then this is 36 by 4, which is 9. So now you had a condition that B must be, right, what? B must be greater than 3, right? Do you have any option that way? Let's check it. Right. So let me read this carefully. So when I say this is greater than this, then, so let me correct this. So this is something like b less than 3, right? So this is b less than 3 actually. So here 3 greater than b, that is b less than 3. Now there is one option which exactly fits into this, and that is option A. So the answer for this question is option A. The remaining options talk about 4, 8 and 2. So let's go to the next problem. Now this question, it's a very standard formula. So let me write this formula here. So what's that formula? D by dx of integral u of x to v of x f of x comma t dt. So what's the formula for this? The formula for this is, it is f of x comma v of x into the derivative of v of x, okay, minus f of x comma u of x into the derivative of u of x, and then we have few more terms like this, plus integral u of x to v of x dou by dou x of f of x comma t dt. It's a direct formula. Now you are given all the information, okay? So you are given u of x, v of x. What is v of x? In the problem, v of x is x. In the problem, v of x is x. So when I substitute v of x as x, so here you have x comma x into, because v of x is x, into the derivative of v of x, right? So this is something like dv by dx here, and here also it's, yeah, du by dx. So here you get 1, and here you get f of x comma x, and there is only one option that way, that is f of x comma x, and that is option B. There is no other option that way. So the answer for this question is B. Let's go to the next question. Now it's a change of variable problem, okay? So what's given? Finally, what are you supposed to find is, you are supposed to simplify this integral. So what is that integral? Let me write. So it's triple integral u minus v whole square by uv into exponential of minus u plus v by 2, and then you have this dx, dy, dz. So they have gone for some substitution, okay? So where they use the new variables which are zeta, eta and phi. So some relation is given. So we need to convert this everything in terms of zeta, neta and phi. Their limits are given, and please remember, when you are going for the change of variables, there is Jacobian coming into the picture. So how do you find the Jacobian? Even the Jacobian is provided. So what I need is, I need dou x comma y comma x comma y comma z by dou this zeta and then neta phi, okay? So something like this. Is that given, right? But it's not given, but its reciprocal is given. So its reciprocal is given as eta square minus neta square whole power minus 1. So I'll take reciprocal of this to get this direct expression, which is zeta square minus neta square. So I know the Jacobian. Now what I'll do is, what is u minus v? In the problem, u minus v is something like 2 neta, right? So I'll substitute that here. So let's see what is uv, right? When a plus b is given and a minus b is given, we can easily find ab, right? How do you find that? A plus b whole square minus a minus b whole square is nothing but 4ab. So use that relation. So what will be this u? So what I want uv. So how do I get that? U plus v whole square minus u minus v whole square is simply 4uv. Okay, so now you can take this 4 to this side. Okay, you can take this 4 to this side. So you have 4 here. So when I square them, so what do? When I square them, this is zeta square, this is neta square, which has 1 by 4 already. So it is simply zeta square minus neta square. Okay, so now everything is all set. U minus v whole square can be written in terms of zeta and eta. uv can also be written in terms of eta and zeta. There is some cancellation, right? So let's proceed with this. So what we have is, we have something like this. We have triple integral. What is u minus v whole square? It is, I think, what is u minus v whole square? U minus v whole square is 2 neta. So 2 neta square is 4 neta square divided by, what is uv? uv, right? So this is 4 uv by 4, which is uv. So that is nothing but zeta square minus neta square. And then you have got this exponential minus of, what is u plus v by 2? U plus v by 2. U plus v by 2 is zeta. So you can substitute that. So that is what? Zeta. And then you come, like, you have this Jacobian. So what is the Jacobian? Jacobian is zeta square minus neta square into what next? Into d zeta d neta d phi. Do you know the limits of all these variables? All these variables limits are given. So let's do the cancellation. This gone, and then whatever is left you can easily integrate. So let's integrate this. Let's write the limits. So the limits of, what are the limits of phi? The phi limits are 0 to pi. Okay, this is 0 to, I think, let's check the limits of pi. The limits of pi are 0 to 2 pi, and zeta are 1 to infinity, and neta are minus 1 to 1. So let's write like this. This is from minus 1 to 1, and then 1 to infinity. So what we have is e power minus zeta, and then 4 neta square, and then d zeta d neta d phi. So if you integrate this, you get the answer. You get the answer as 16 pi by 3e. I'm just leaving the integration to you. So let me go to the next problem. So now this problem, I have to go for verification of the options. I need to go for verification of the options. So I'll start with option D because it is the only option which satisfies. Usually what happens is students start with A, so there are certain terms that get cancelled. So when you solve option A, you get what to be taken next, right? A clever student, after verification of option A, he'll go with option D. So I'll directly verify option D. So look at this, how I'm going to verify this. So what is xi, right? So xi in the option A, option D, okay, option D, it's given as f of 2x minus y, okay, e to the power minus 2x square minus 2y square plus 3xy whole divided by 5. Now I'll substitute this into the partial differential equation. So what's the first term? So based on the first term, you can guess the second term as well. So dou xi by dou x equal to, it's a product rule, so I'll keep this as it is, f of 2x minus y into e to the power of minus 2x square minus 2y square plus 3xy by 5 into the partial derivative of this with respect to x. So what will be that? The partial derivative of this with respect to x. So it is minus 4x, okay, minus 4x plus 3y and then whole divided by 5. So I'm done with this into the derivative of this. Now I'll keep this term as it is and go for the derivative of this. Okay, it's a detailed verification process. So there are many twists and turns here. So plus e to the power minus 2x square minus 2y square plus 3xy whole divided by 5 into the derivative of f of 2x minus y, which is f dash of 2x minus y into 2 because of the derivative of 2x. Now what is this? This is dou xi by dou x. In the same way, you need to find dou xi by dou y. So let's see what is that dou xi by dou y. So again, you need to go for the product rule, but the partial derivative is with respect to y. So dou xi by dou y is, I'll keep f of 2x minus y as it is, and then e to the power of minus. So what's there? It is 2x square minus 2y square plus 3xy whole divided by 5 into the partial derivative of this with respect to y. So what's that? So this is the first term is 0. You need to be careful with this minus signs. So it's 4y, and then plus minus into plus is minus, and then 3x divided by 5, and then one more term is left over. What is that term? So that term is plus this term into the derivative of this, that is minus 2x square minus 2y square plus 3xy. What I'm doing is simply the product rule. So this is f dash of 2x minus y into the partial derivative of y this time, which is minus 1. Okay, now you have dou xi by dou x, you have dou xi by dou y. What is asked is dou xi by dou x plus twice dou xi by dou y. That was interesting actually while solving this. So what was asked? Dou xi by dou x plus twice. That is very important. Let's add them and then put 2 here. Okay, let's minimize this. I need to add them properly. So let me add this. So what is dou xi by dou x plus twice dou xi by dou y? So let's see that. So now in all the terms you see e power minus x square, this whole term is common. So let me put that out. So e to the power of minus 2x square minus 2y square plus 3xy whole divided by 5 is out. What is left? So now you can see that in this and in this f of 2x minus y is also common. So f of 2x minus y is common. So what is left here, right? You have to be extremely careful because you need to multiply 2 as well. Okay, so let's take common. What is left? Minus 4x plus 3y by 5 and then plus 2 times what? 2 times of this, which is 8y. Okay, 8y minus 6x whole divided by 5, right? And then you need to take this as well. Okay, so anything cancellation. See here, there is a cancellation because this is f dash of 2x minus y into 2, and this is minus f dash of 2x minus y, which is now multiplied with 2, they get cancelled. Okay, so that's a killer point here. So now what should I do now? So let's rearrange this. So when I rearrange this, it is, let's see what happens. Minus 4x minus 6x minus 10x by 5. Okay, so let me simplify this. So it's minus 10x plus so did I miss anything? There is a minus sign I think I have missed. So let me check that. So there is a minus sign that I have missed. So what is that minus sign? So here I have a minus that is multiplied. Yeah. So is there any minus sign? 4y minus 3x, it's multiplied with this, and then minus 4x plus 3y. Let's see what's happening here. So it's 3y plus 8y. So it's how much? 11. Why? I think I have missed something here. So minus is plus here. That's okay here. And then is there any term? I think looks like I have missed something here. So 4y. This is minus of minus is plus, and then this is minus 3x, and I'm adding them. So it's 4y into 8y. So I have missed some term here. So I have to get something common here. So when I do that, okay, so what I get is I end up with this as the answer. Which one? Option D as the answer. Okay, so that's how dou f by 4y minus 3y. I think there is
there is a minus that I have missed, so you cannot check it, so you can solve it. This is how the procedure is. The answer for this question is option D. Okay, so let's see if we have any other question. Yeah, that's it for engineering mathematics. So the next, we are now waiting for the Ramesh sir, so he's going to take questions from measurement subject.
Right. Now I'm going to discuss the questions from measurement subject. The first question here is statement 1 and statement 2. When the signal is of the form of current. So what is the signal form here? Form of current. Then the series input devices are used. Definitely, in order to measure the current, we need to talk about the series connected device, that is ammeter. So therefore, statement 1 is correct. Second one is statement 2, an ammeter, which is a series device. Of course, ammeter must be connected in series only. Thus, should be designed with a low input impedance so that the current is correctly measured. Definitely, ammeter must be designed with low resistance. Therefore, automatically, we are going to have the corresponding, right? The answer is correct. So therefore, the value will be correct only. So therefore, statement 1 is correct, statement 2 is correct, and then sir, statement 1 and statement 2 both are correct, but both are dependent or independent, means statement 2 is the correct reason for statement 1. So therefore, statement 1 is correct, statement 2 is also correct, and but both are dependent. Both are dependent, we can say. So therefore, option A is the answer, direct answer. Right, now let us see the second question. Next one is here. The torque generated in the aluminum disc of an induction type energy meter. Kindly focus more on this word. This is not just induction type, because induction type what meter is there? Induction type energy meter also. That too he has mentioned induction type energy meter is maximum. So therefore torque generated will be maximum. Torque generated should be maximum when the phase difference between the magnetic fields of shunt as well as series. Direct question. Sir, in order to have the corresponding maximum torque, the phase angle between these two must be 90 degrees. So therefore direct solution, direct answer 90 degrees. This is direct question from our material also. Right. Next question here. A DC galvanometer of 4 ohm resistance reads up to 50 milliampere. What is the value of the resistance in parallel to enable this instrument to read up to 1 ampere? Sir, this is the direct question from the extension of range of ammeter. Sir, parallel resistance means directly we can say RESH is equal to REM by I by IM minus 1. I by IM minus 1. What is the meter resistance? 4 ohm by current is, it is to be extended to 1 ampere by meter current is 50 milliampere minus 1. You will be getting so and so answer. You are going to get the approximate value as 0.21053 ohm will be there. If you understand this, yes, 0.21053. Option A is correct. Direct question. There is no difficult numerical. Approximately we can check it. Right. Next question. Here, which one of the following statements is not correct for electrodynamometer type instrument? You must be very clear. He is asking about not correct. He is asking about not correct. What is that? It can measure a range of currents and voltages up to 10 ampere and 600 volt respectively. This statement is correct, but he is asking not correct. So therefore, it is not the answer for this question. Second one, the deflecting torque is inversely proportional to the square of the current. Strictly speaking, the deflecting torque is proportional to square of the current. Therefore, this is wrong. He is asking not correct. Therefore, according to the question, this is what the answer. But let us have a look. It can be used for both AC and DC. This is correct. But he is asking not correct. Be clear. It has the same calibration for DC as well as AC. Yes. Therefore, it is called as transfer instrument. Therefore, A, C, D are correct. B is wrong. Therefore, correct answer for this one is given question which is not correct means B is the answer. Right. Let us take one more question. Here. The controlling torque of a gravity controlled measuring instrument is directly, sir, controlling torque is directly proportional to sine theta based on the fundamental concept. Yes, answer D is the direct answer. Right. Let us take one more question. Lengthy numerical, right? But without calculator, approximately you can calculate, but somewhat lengthy numerical they have given in this. The arms of a 4-arm bridge, right, ABCD, this is ABCD, supplied with a sinusoidal voltage have the following values. And arm AB, a resistor 200 ohm in parallel with a capacitor of 1 microfarad. BC is 400 ohm and CD is 1000 ohm. Arm DA is resistance R2 in series with 2 microfarad. This is microfarad, 2 microfarad. And what he is asking, find the value of R2 and frequency respectively. Therefore, the point here is, here itself I am writing the values directly. Sir, resistance AB I am taking as R1, this is C1. And BC I am taking as R3. And CD I am taking as R4. And D I am taking as S. He has given R2 and this will be C2. Right, sir, he is asking R2 as well as frequency of the bridge. So therefore, this is somewhat numerical based one. Sir, this is a Wien's bridge, we can say. This is A, B, C, D. Here they have given R parallel with capacitance, resistance, and here they have given R and C. This is our R1, C1, R3, R4, R2, C2. These are the point. And here supply, that is common point. Sir, in this Wien's bridge, sir, which are unknown means R2 is unknown. Of course, frequency of the bridge is also unknown. Frequency of the bridge is also unknown. So directly one formula is there. In the Wien's bridge, while I was explaining, I told you, after applying the balancing condition equation, what we are going to get, that is R4 by R3 is equal to R2 by R1 plus C1 by C2. You observe keenly, from this, if you substitute all the values, R1, C1, R3, everything is given except R2. Have a look on this. Yes, I have written R1, C1, R3, R4, C2 is given. R2 alone is not there. Therefore, if you substitute all those values, you will be getting R2 value as, I am giving the value, R2 value you are going to get is 400 ohm. R2 is 400 ohm. But if you see the options, right here, 200, 200, 400, 400, so automatically these two can be cancelled out. But unfortunately, two options are with 400 ohm. Definitely we need to go for frequency calculation. That is, next one is, what is the formula? F is equal to 1 by 2 pi root R1, R2, C1, C2. If you substitute all the values, because 2 pi anyway, R1 is there, R2 we have obtained, C1, C2 are there. If you substitute, you are going to get 397.88 heads will be there. Approximately we can say 398. Now go back and see the options. Here, yes, second option is there, direct one. In this formula based but numerical value, you need to be more careful here. Right, let us take one more question. Here, consider the parallel circuit having. Here, you need to be very much careful. The moment the people are observing the parallel word and three currents are given, three values are given, they are getting confused like parallel, three elements, very lengthy. That's why people are leaving this. But strictly speaking, these are not resistances. These are currents. So therefore, in the parallel circuit, currents are given. So therefore, what is I total? I total is equal to I1 plus I2 plus I3 directly. Therefore, and errors are given in standard deviation form. So directly, sir, I1 50, I2 100, 150 and 200, 350. All options are 350 only. So we must be able to concentrate on error value. So therefore, what is that? So standard deviation of I total. I told you in the class. What is the direct procedure? I1 to the power 1 is there into I1 error is 2 square. I2 to the power 1 into I2 error is 3 whole square plus I3 power 1 into 5 square. If you simplify this, sir, 4, 9, 25, if you are simplifying this, you will be getting 6.16 amperes. That is standard deviation. Only one answer is there. That is, of course, C option. Yes, 6.16 will be there here. And let us take one more question here. In this, which one of the following is not a self-generating? Which of the following is not a self-generating transducer? Now, if you observe this entire thing, not a self-generating type. So therefore, sir, if you are observing all these, we will be having the corresponding generating types, self-generating, etc. Therefore, you can use this as it is value. And from this, you can select Bourdon gauge for the measurement of pressure, pitot tube for the measurement of, and thermistor for the measurement of temperature, and photovoltaic cell is the corresponding temperature. Here, let me check the question clearly once, whether it is typed clearly or not. 116th question, let me check once. What is the thing he is asking? Right, which one of the following is not a self-generating transducer? Out of all these, which is the not self-generating means what? Simply thermistor type is a resistive notation. So therefore we can say thermistor comes under resistive. Resistive means automatically we can say yes, that is what a passive transducer, not a self-generating transducer. That's what the answer. Right, next one is the approximate range of gauge factor for a semiconductor strain gauge is. Semiconductor strain gauge. So we need to concentrate here. Sir, in this entire thing, the approximate gauge factor generally for semiconductors, high value will be there. Yes, this is the direct range. 100 to 200 is the direct range. And let us go for next question. It is also direct value based. The approximate pressure range for ionization gauge is direct value guys. 10 power minus 8 to 10 power minus 3 torr. So direct answer 10 power minus 8 to 10 power minus 3 torr. And let us take one more. A half wave rectifier type AC voltmeter is fed with 20 volt RMS. 20 volt RMS. Right. What is the equivalent DC output voltage? Be clear, he is asking DC output voltage. Be clear here, he is asking DC output voltage. Sir, as it is a half wave rectifier, what we can say now in this, VRMS is given as how much? 20 volt. And sir, what is VRMS formula? Vm by root 2. Vm by root 2. Right? This is half-wave rectifier type instrument, not the rectifier output. So VRM is this one. So therefore, Vm is equal to 20 root 2. And then, sir, DC output voltage means V average is equal to Vm by pi. That is 20 root 2 by pi. 20 root 2 by pi. You will be, if you are simplifying, you will be getting approximately answer as 9 point something or 9 volt we can say. Very, very simple, direct straight away question. Now, next one is very lengthy question. Very, very lengthy question because this is oriented shunt based question. Now in this, he is asking 100 milliampere, 1 ampere, 10 ampere and 100 ampere. 4 ranges they have given. For each range R4, R3, R2, R1. This is completely, I am clearly saying that this is very, very lengthy model. Very lengthy model. And how to answer this means very simple. Sir, RSH is equal to Rm by m minus 1. If you follow this formula, you are going to get, suppose I am taking here total value 100 milli, you are going to get the total resistance here. That total resistance will be around RSH, this total R1 plus R2 plus R3 plus R4. Around you will be getting 2.36 something, approximately 2.4 near value. But unfortunately, if you see all the values R1, R2, R3, R4, if you are adding all for all the options, it is coming around 2.4 nearby. So therefore, in all the options, right, if you are adding all the values, answer will be same. That's why you need to be very much cautious here. Sir, in this, if I am taking this point, by joining all those, you are getting 2.3, etc. But out of all these, very simple guys, 100 milli to 1, 1 to 10, 10 to 100, etc. I mean ranges keep on getting increased. Therefore, automatically the R4 to corresponding this entire value one order should be there. If you follow that order, that is simply, if you are simplifying that, you are going to get the answer. That is, first option is the answer. But logic here is 0.002 R1 small value. It is 0.018, 0.18 and R4 1.836. Answer will be this. But point here is, What is that? RSH is equal to RM by M minus 1 only. But if you are simplifying that very lengthy one, just take this one. You should not waste the time in this question because the question is very lengthy. That's why these type of questions must be written or attempted at the last of the entire paper. So these are the complete questions regarding the entire subject. And not only from measurement subject, this is the end of all the questions from electrical stream. That's why after going through all the questions, those who got good marks, etc., congratulations to them. And those who are waiting, those who are preparing, getting ready for the preparation of mains exam, all the best. Thank you.